So good morning, everyone. Nice to see you here. We are starting the session right now. I wanted to thank Gianfranco, first of all, for the really beautiful location of the social dinner we had yesterday. Great food, and we really had fun. And yeah, I'm happy that at least some of us, it's already in this room right now. I'm happy to invite the first speaker of the day, Luis Duarte from the institution LNAG-UBB in Portugal. He will give a talk about the pros and cons of upgrading fruit and vegetable wastes in the biorefinery framework. Luis, the floor is yours.
Thank you very much. Good morning, everyone. Thank you for the opportunity to present our work and the work of my lab. I'm going to start to explain where I come from. I come from the National Laboratory for Energy and Geology. It's a national research center situated in Lisbon, Portugal. And well, we mainly do research. We are not a university, and we do applied research together with companies and so on. And we are open to collaboration. So actually, this is one of the first methods that I would like to convey. If you see something interesting in the coming slides, in the end, you can talk about some possible collaboration for STSMs or something like that. So what we do, we start as a national lab to understand what's available in Portugal, what kind of feedstocks are available. For instance, we have a map that allows us to evaluate the potential for the production of energy crops, for instance. But we go beyond that, and we also like to combine geographical and statistical information resource in order, for instance, to estimate the amount of agricultural residues available. And we can do that for different crops in Portugal, where we aim from corn stover, olive tree prunings, phosphate prunings, and other materials. So we can have a complete look at whatever is available. We also do the same for the agro-food industrial residues. And for instance, we have a database that covers where the companies that deal with this kind of substrates are available in Portugal, and also on the availability of the feedstocks that are present. But as you know, these materials are not created equal. They are quite different among themselves, namely the biological nature, the chemical composition, and structural difference turn them to be difficult to upgrade and to have a... Oh, yes? Talking too loud?
Yeah, the microphone, it was a little bit sharp. So.
Okay. Better now? Everyone is... Okay. So what I was telling you about is that different materials present different biomass compositions, and this doesn't impact on how you can upgrade them. So we want to estimate what is the upgradability of a given material. And so what are the main restrictions for its use? What are their strengths, their weaknesses, or their opportunities and threats, of course, and when they can be used, for instance, because seasonality is an issue also in the upgrade of these materials. So a few years ago, we developed a concept that allows us to evaluate the upgrade potential following four main criteria. That is the biological and physical chemical, the economical, the technological, and geographical. I'm not going into too much detail about this. We can then have, well, talking over the coffee break if you want. But basically, you just give a score between 0 and 3, while 0 is an undesirable characteristic and 3 a strong positive impact on the upgrade. And you have things like the biological nature, the macromolecular composition, for instance, it has a lot of protein, or it has a lot of lignin, or what kind of sugars are present, the water content, and the economical factors, things like seasonality, costs, and market dependency. And then the technological factors, how advanced is the technology to upgrade these materials, or the current applied destinations that are competing with your use of your feedstock. And finally, the geographical factors that refers to the quantities that are available, of course, and in the end, the political legal constraints that sometimes, regardless what we have before, they say the go, no go for the upgrade of these materials. In fact, the concept is quite easy. You just add up, but more important than the score that you get for each feedstock, it's important to see how these different factors are distributed among them. And this is exhaustive list of the available feedstocks in Portugal. But we can see that there are many advantages like no seasonality, the quantities are okay, but there are undeveloped technologies and lack of national support. And that sometimes is a problem. But more important than the score, as I told you, is the ability to do some analysis on these results, and then we can see how these different or these specific materials fit into specific groups. And then you have the feedstock for the biorefinery thermochemical platform or agro-industrial co-products that because of they are co-products, they will not be so much useful in the biorefinery, or the feedstocks for the biorefinery biochemical platform that I will focus now, even though some of the examples will come from the thermochemical platform because we like to take risks and we like to go beyond what is easy to do. So one of the feedstocks that we have identified is carob. It's very common in the Mediterranean countries and in Portugal, and I would like to discuss with some of you what happened in your countries, but in Portugal it does not have a significant utilization. The carob has a high content of sugar, it is producing significant amounts, is highly geographically concentrated, and actually there are favorable policies in that because the carob plantation is being subsidized. But the question is the price, and because it can be used for doing some confectionery and some bread, of course, but yeah, for those of you that know carob, it has a specific taste, and so although it's palatable, it's not that good, and so there's a lot of feedstock available afterwards. And based on this, we have developed a valorization strategy, actually, and where we try to do very simple processes in order to upgrade it. And based on aqueous extraction, we got a liquid phase and a solid phase, and the liquid phase, we divided it into fermentation, and we got 2 patents out of this, and one for producing mannitol, that is a sweetener, and another one for producing a polyfunctional drink. And a polyfunctional drink, because it's antioxidant, anti-hyperglycemic, it's a probiotic, and it's no dairy. So it's pretty much like a Mediterranean type yogurt without being produced from milk. And on the solid part, remaining solid part, we do a secondary extraction now with a solvent extraction, and we get a wood fiber that can be used also for food applications and lacks the typical carob taste and smell. And we also get bioactive extractives, and we found out that these bioactive extractives can be used as, and we have patent also on that for the control of, cancer development, let's say. But we believe that we are really on the upcycle food definition, in the sense that upcycled foods are ingredients that otherwise would not have gone to human consumption, are produced and produced using verified supply chains, and they have a positive impact on the environment. I think we manage that. And I think these also go into the upcycle food elements and, the rules that it has to comply. But this was, as I said, a very nice material, carob, but there are other ones, more recalcitrant, typically non-edible materials, and we are talking, for instance, extracted olive pomace, almond shell, corn cobs, or pine nut shells. So, but what you can do with that? And then you can use them already in the biorefinery framework, of course, with the same target, but you need to have different kind of process involved. And instead of just adding water and do the extraction, you need to have other chemical process or physical chemical process to get the structural materials out of it. And when we're talking about extractives, the structural materials, we're talking about hemicellulose, the lignin, and the cellulose. And we focus mainly in our lab on the chemical and physical chemical processes, namely in liquid hot water. And with liquid hot water, we were able to fractionate and upgrading step on a single step. And we can produce xylo-oligosaccharides. Xylo-oligosaccharides are now recognized by FDA as additive components to be added for foods. They have a high market value, but unfortunately, still a low market demand. But we hope to increase in the near future. And what comes about is then we can use these oligosaccharides to produce also monosaccharides, namely xylose, that will be the main sugar that come out of it. And from xylose, we can go again to other polyols, and namely xylitol. As you can see, xylitol, probably all of you have used xylitol already in chewing gums. And so I think this brings me almost back to the final time and to my take-home message. So BVPI can be a useful tool to ascertain the appropriate potential of a given material. Actually, in this context of this work, I would say that it might be considered a useful starting point for the development for more robust classification criteria for food waste products. And of course, the biorefinery concepts are useful for the upgrade of food waste materials and enable their maintenance and upscale of food products. And finally, to thank all the people that have worked to produce these results. I'm just showing here an overview of what we do in the lab, just to bring up some ideas during the several projects that we have carried out, namely BRISC-2. And so we are used to have people coming to visit our lab because we were one of the rigs in BRISC-2. And to invite you to the Biorefinery Congress that we are organizing in Spain in October this year. Thank you very much. I think I even was before time.
Thank you, Luis, very much. Thank you for keep the time and for the very clear presentation. Do we have any questions for Luis?
So, talk over the coffee break?
Yeah, well, I have one question, actually.
Please, yes. Welcome questions.
What about the exhaust biomass of the distillation of medicinal and aromatic plants?
Actually, we are also doing some work on that. In Portugal, we have, I haven't shown the results from this, but in Portugal, we have a very common Mediterranean spontaneous plant that is called Cistus ladanifer, that where we extract labdanum. That is very useful for the pharmaceutical industry, and the essential oil also is very expensive. Let's say 10 milliliters around 100 euros. So it's a high value product, but it's in very, very low amounts. And so we get a lot of biomass out of it. And so after we get the oil and we get the extractives out, then we can apply the biorefinery concept that we have applied here. And in fact, we have a few works on that, and we are not only targeting the hemicellulose upgrade, but also the lignin. And because we can also recover some of the compounds from lignin, and then we have another class of bioactive compounds like antioxidants and things like that we can test. Thank you.
Thank you again.
Thank you. So now we can pass to the next speaker is Eduardo Espinosa from the University of Cordoba, Spain, to present for us about sustainable packaging solution based on the circular valorization of agro-industrial products. The floor is for you.
Thank you, Marwa, for the presentation. Good morning, everyone. My name is Eduardo Espinosa, an assistant professor in the University of Cordoba in the Bioprocess and Product Engineering group. Well, we always focus our research on the valorization of agro-industrial byproducts, especially to apply like a alternative fiber source for the papermaking industry. We also use this fiber for the preparation and production of biomedical device. But in the last years, we started a collaboration with the IBRO group from the food science technology led by Fernando Pérez Rodriguez. And we try to apply the different bio-based fraction that we can obtain from the agro-industrial byproduct in several systems of packaging for increase the food life, the food cell life to like a strategy to reduce also the food waste in household and in distribution. We talk too much this day about the importance of reduce the food waste during the inter-food chains, especially when we are talking about the effect of the packaging on the potential of reduction of the food waste. We have to focus on the retail and the consumption stage. So we have to change our mind. The packaging nowadays is not only a solution that protects the food from the external environments. Nowadays, we have a different concept of packaging. We know that we are developing active and smart packaging. When with this active packaging can interact with the food to increase this life, and the smart packaging show real-time information to the consumer about the status of the food that are packed inside. So this old concept, now we have to move towards the new concept one. Not only to change the mind in this concept, but also look for new bio-based sources for the developing of this packaging. Normally, the packaging are produced from oil-derived polymers, but they have several problems. For example, we see the constant fluctuation in oil price, also the high environmental impact that they produce, and of course, the new regulation, for example, the single-use plastic directive that force us to change this material to a new sustainable ones. So we are looking for new bio-based packaging solution, and the natural biopolymers are a good substitute for the petroleum derivatives polymer. They provide an effective alternative for the production of environmentally safe packaging material, and we try that they meet the market requirement by the combination of several bio-based fractions. We try to valorize several fractions from the byproducts, the natural extracts, the heteropolysaccharide, the cellulose, the nanocellulose, and apply them in different packaging systems. We work in flexible films that we can use in living rigid trays, for example, in bags, in sachets, in absorbent pads, coatings, and fiber-based trays for its use in the market. For example, for food packaging films, we know that we can use several bio-based polymers, but normally these biopolymers that have a lot of advantages because they are biodegradable, biocompatible, not toxic, water soluble, they present a good film forming ability. So for example, the ketosine present antimicrobial, and they are bio-based, but they present some limitation. For example, they have limited thermal barrier and mechanical properties, so it doesn't meet the requirement expected for the market. So one of the solutions is blend this biopolymer with nanomaterial, with bio-based nanomaterial. For example, the nanocellulose. We use this nanocellulose to improve this mechanical resistance and these barrier properties of this biopolymer to increase this performance in the conservation of the food that we pack inside. So nanocellulose is a very promising material because it's renewable. We can obtain from several sources of fiber, and it's present a high specific surface and have a lot of hydroxyl carboxyl group on its surface that can be combined and can interact with the biopolymer that we use for the packaging solution design. So we obtain nanocellulose for several agro-industrial byproducts. We combine with the polymer, we perform the field, we evaluate the properties that they show, and we can also produce the bioactive films if we combine the polymer, the lignocellulose nanofiber, or the cellulose nanofiber with natural extracts of pectin. If we want to confer these bioactive properties to the final film, not always is necessary. If we want, we can do it. So about the use of nanocellulose as reinforcing agent in film materials, we can cluster the nanocellulose in two types: the high quality nanocellulose that we can obtain from grease raw material, for example, the cereal straws and the peels of food processing byproducts, and the low quality material that we can obtain from horticultural residues and for prunings. I talk about quality, about the easy implementation of the delamination process of the cellulosic fiber to obtain this nanomaterial with a low diameter. So because nanocellulose with low diameters show a higher specific surface and it's easier to interact with the polymers that are surrounding. So with just 3% of nanocellulose or 5% of nanocellulose, depending on the quality, we can increase the mechanical performance of the films. We can enhance the barrier properties because we are increasing the tortuosity that the gases have to pass through the matrix. And if we remain a residual lignin content in the fiber or that we use for production of nanocellulose, we can increase the UV light blocking capacity, and we can confer this antioxidant capacity also to the final properties. We can also add bioactive properties, in this case natural extracts, to have a full protection against UV light and antioxidant capacity. And we can also combine this both fraction to control the release of these bioactive compounds to the food or to the inside of the packaging. And we can also add this heteropolysaccharide, for example, pectin, to confer also bioactive properties to the final films. We also test the production of bags. Normally, PLA have a lot of advantages, but also presents some disadvantage that we try to solve by the addition of nanocellulose to increase the flexibility and to increase the optical properties of the final material. We obtain this cellulose nanofiber from weight, and we add in a pilot scale blowing extrusion machine to produce this bag, and use this bag for the conservation of fresh good lettuce and compare with the commercial solution. And we find that the performance was similar, so we are producing more sustainable material than the commercial one or the commercial ones. About sachets, we can also use these biopolymers to the production of sachets, for example, for oil preservation. We combine different biopolymer with acorn seal extracts, and we observe like chitosan in combination with natural extract reduce in a significant way the oxidation of oil that is packed inside the sachet. So it's a very good alternative from the plastic solution that we have nowadays in the market. We can also use this biopolymer fraction from the production of absorbent pads. We can also combine the advantage of chitosan, that they are non-biodegradable, antimicrobial activity, etc., with the high mechanical performance of cellulose nanofibers in order to increase this absorption capacity to the pads. So we produce chitosan and cellulose nanofiber aerogel to use it on an absorbent pad in packaging. We additivate with natural extract to confer these bioactive properties, and we observe how when we apply in meat preservation, we reduce the oxidation of oxymyoglobin to methmyoglobin, so we can increase the quality maintain of the meat when we pack this. Well, we'll talk also in this cost action about the production of edible coating by the using of different biopolymers. We can also use lignocellulose nanofibers to improve this coating solution. For example, we find that we can use in cucumber to substitute the plastic that we individually bake this cucumber, also in raspberry, to increase the shelf life of this product. And we find that adding up to 10% of lignocellulose nanofiber, the performance of this coating, of this edible coating solution, increase a lot. So it's a good opportunity to have high performance coating solution. And just for the last demonstrator is that we can obtain also fiber-based trays, not from wood fiber, that is the normal product that we can find in the markets. It's not from horticultural waste valorization. We have a patent that we obtain mechanical fiber just with mechanical treatment, so we avoid the production of liquid or black liquid that is very typical in the paper making industry. We obtain the fibers and we apply this fiber in the production of rigid trays, so for ready to use or ready to eat fibers food. And we find that we can add to the dry up to 60% of fibers obtained from horticultural waste. So just the last, we want to announce that we have just get budget for start a new Prima project in the last call within the section 2. And we are going to develop this project in the same framework that I presented, in the obtention of several active packaging to increase the shelf life to the products and trying to reduce the food waste in the distribution and the household. We are going to develop this active coating, the flexible pin, absorbent pads, and small indicators under a microbiome design approach. So I think that we can collaborate, or we will launch the project in the next month, and so it is in the framework of this action course. So a lot of collaboration can happen here. Okay, so thank you for your attention.
Thank you, Eduardo. It was very good presentation, really, and package for this sustainable packaging that we know all that packaging has big role to reduce the waste and to extend the shelf life of the product. So we will see if we have some question for Eduardo. Okay, we have a question.
You mentioned I missed, but what was the previous the shelf life of the products
Which one?
for the packaging?
The sunlight product?
Shelf life. The second project is to increase the shelf life of your products.
Yes.
And I'm wondering what was the previous one and what's your target to reach?
The objective. Or we are going to test several food bioproducts. Also, there's several food products. So depending on the food product, we have vegetable in our target, also meat and fish, or depending. But it's like an increase of 20% in the shelf life of the product. So normally it's like 2 or 3 days. It's a good target, I think so. Yes.
Thanks for your presentation. Have you also considered bacterial cellulose for the production of nanocellulose for your purpose?
Bacterial cellulose?
Bacterial cellulose.
Bacterial cellulose. Yes, we work with bacterial cellulose, but this bacterial cellulose is, I think, it's more expensive to obtain than vegetable cellulose because the process is more technological. And we work with bacterial cellulose for the production of biomedical device because the high purity of these bacterial nanocellulose. But we work also with this bacterial cellulose in the production of edible protein because they are with bio-based and biosources. And we get similar results from the vegetable cellulose nanofiber. So I think the bacterial cellulose is a perfect alternative to the normal nanocellulose to apply in the same product that we developed. Yes, thank you.
Thank you. Other question? Okay. Thank you, Eduardo.
Thank you.
So let's go on. I invite the following speaker, Professor Tulay Inan from Sabancı University Nanotechnology Research and Application Center in Turkey. She will give a speech about the preparation of multifunctional composites for electromagnetic interference shielding applications using tomato wastes.
Thank you for the presentation. Thank you for the opportunity to present our newly accepted project in this platform. And I'm not going to give you the results from the project, but I'm going to talk about mainly the plan that we are going to make for our newly accepted project. Yeah, I will give some background, our motivation, and the project summary and acknowledgement. I'm the working group member of 4 and 6. And as I mentioned, one of our newly accepted projects, I'm going to talk about. From the yesterday's presentation, we all know that world population is increasing and there's an important climate change, so temperatures are increasing. We need clean water and we have limited food sources. That's why we have to use our resources and waste very carefully. And the sustainability, recycling, upscaling, environment-friendly and climate-friendly technologies are becoming very important terms. And that's why we have to very careful on our resources and also waste sources. I choose electromagnetic shielding applications because in today's fast-paced digital world, electronic devices have become an unavoidable part of our lives, and consumers are demanding for more properties. If you have electronic devices, you look for good electronic properties, but also you ask for waterproof, flexible, flame retardant, lightweight, cheap, or antibacterial properties. You can add more and name it. So multifunctional materials are going to be very important, especially for wearable electronics. It's becoming very important. And these electronic devices conducing to increasing electromagnetic interference, which of course affect our health badly, as well as the sensitivity of our electronic devices. That's why developing highly effective multifunctional EMI shielding materials are of great interest and importance. We published one review article about this subject. So our project will be mainly on electromagnetic shielding applications. Of course, the technology requires high conductivity, permeability, permittivity, processability, corrosion resistance, while being cost-effective and environmentally friendly. And why not to use lignocellulosic biomass? We have different, of course, biomass sources. These are rural, urban, or industrial biomass. And we concentrated mainly on industrial biomass and for agri-food industries. Because I'm a chemical engineer and also polymer chemist, that's why I mainly concentrated on polymeric part of the lignocellulosic biomass, which is cellulose, semicellulose, and lignin. Depending on the source, the cellulose, semicellulose, and lignin contents are changing enormously. And if you look at agricultural sources, even the same agriculture with different kind of types change, their contents are changing, lignin, cellulose, and hemicellulose contents. In this project, we are going to mainly concentrate on tomato pulp. And the motivation for this is that Turkey is among the top 10 tomato producing countries in the world and has produced 42% of tomatoes alone in 2020. So it makes 13.2 million tons, the first place in vegetable agriculture in Turkey. And naturally, we have important amount of waste to be used for valorization aims. Yeah, we are in the rank of among the top 10 tomato producing countries. So we are going to use pulp pomace, or we can call it pomace, and the fiber parts change between 40 to 60%, 70% for some types of tomatoes. So it's the subject is in the priority issues in all UN and EU strategy documents, and also 15 national development plan of the Turkey. There are different, of course, the speakers, Eduardo talked about cellulose production, and there are different kinds of cellulose, and they are named in different cellulose nanofibers, nanocrystals, bacterial cellulose, and different types of cellulose are existing depending on their diameters and lengths. And our project will be mainly concentrated on using less energy required processes, and also less water requiring processes. That's why actually there are some ionic liquids and water is used in the commercial, conventional extraction processes, but they are costly, they have lots of steps, and we are talking about using our resources in an efficient way, but we are spending lots of energy and also water, although we have less amount of water. That's why we need to concentrate on low energy, low water required technologies, processes, and also solvents. And in this project, we are going to use deputative solvents, and the processes will cover microwave, ultrasound. We have, if we need, we can use, of course, mechanical methods as well. And since we are talking about electromagnetic shielding applications, we are going to use new emerging material MXene as a electromagnetic shielding conductive material. And also we need to use electrospun production method to get these kind of materials. Maybe I should talk about a little bit electromagnetic wave attenuation. There are three mechanisms. One is reflection. Mainly metallic materials are used, but they suffer from high density, low wear or scratch resistance, corrosion, and high cost. The secondary mechanism is absorption, and we are mainly dielectric materials are used. They are written here, but these kind of materials have narrow band action. Processing is difficult for the EMI shielding. And there is also a third mechanism, which is multiple reflections. It can absorb and reflect, and this is what we are looking for to produce, because, and also it has heterogeneous structure and porosity. When the electromagnetic wave comes, because of the heterogeneity, the corrosive waves will travel a long way, so it will not affect our health and our miniature devices in a bad way. So we are mainly considering composites, foams, and honeycomb structures. And also there are some conductive polymers that can be used for this aim, but they are in rigid structure and processability is not easy. Carbon-based materials can be used for this aim, carbon black fibers, carbon nanotubes, but these materials need to be added in large quantities. So to conquer the three mechanisms, we prefer to use multifunctional EMI shielding materials with low thickness, light, high conductivity, processability, sustainability, and cost competitive products. And we are going to use, as I told you, MXene-based conductive material, which is a new emerging material, and it's a promising candidate for EMI shielding. And of course, the production of MXene nowadays is not very eco-friendly, but there are new methods are developing, so it will be sustainable material soon, it seems. And for who doesn't know the MXenes, I can give in this, I can explain this way. It's a 2D transition material, and it has transition metal given in green. A is the given elements, and X can be carbon or nitrogen. T represents the functionality. According to the preparation method, it can be hydroxyl, chlorinated or fluorinated groups. So you can easily modify for hydrophobic systems and also for hydrophilic systems. This is also another advantage of this material. Deep eutectic solvents are preference because it has hydrogen bond donors and also hydrogen bond acceptors, and water in the conventional systems, we are using water a lot to neutralize alkalinity or acidity of the process products, and we are losing lots of water, and also we are consuming important amount of energy. So ionic liquids can be used for this aim, but these are mainly costly, and there are some recycling problems existing. So we decided to use deep eutectic solvents to make to carry out ionic liquids properties and also easily recycle it. Yeah, our project summary I can give in this graphical abstract. We are going to use tomato hummus, and we will use some nanomaterials, incorporate the polymeric part of this weights to valorize for the EMI shielding materials, producing EMI shielding materials. And so we are also planning to use electrospun production because and we will add some polymers here. There's polymer urethane type polymer, but we are planning to use also natural polymers, even lignocellulose parts of the polymers. So at the end, we are going to have high electromagnetic shielding materials. I acknowledge for the permission of this presentation to my organization and my collaborators. And thank you for your attention and your patience. I hope I didn't pass the time. If you have any question, I can.
Yes, we have space for a few questions.
I need to, okay.
Thanks for a very interesting talk. We will discuss during the break, I suppose. You have mentioned incorporation of vaccines into the electrospun textile, non-textile.
Yes.
Can it be also used for the modification of already existing textile, just by absorption or some specific binding to the existing textiles?
It has to be it's a material, 2D material, but you cannot use it as it is. You need to make it flexible. To make it flexible, you need some polymeric ingredients or fibers. So you can get the preferred flexibility for wearable electronics. That's why we need to have polymeric part. Textile could be polymers as it is, and we need to add this maxin in a yeah, we can add in, how can I say?
So we can discuss during the coffee break, I think, in detail, because it's very interesting for me.
It's natural, as when you produce, it's hydrophilic. So if you are using, depending on the textile you are using, it could be polyester, polyamide, or cotton. If you are using cotton, they are both hydrophilic, so you can use it. But if you are using polyamide or polyester, you need to make it hydrophobic. Otherwise, you can face with agglomeration problems. So you need to modify your maxine according to your needs and then incorporate to your polymeric systems. This is what I mean.
Okay, thank you. Thank you.
Thank you. Any other question?
Okay, thank you.
Thank you. So we can pass to the next speaker. He is Rajev Bhatt, Eracher in Valor Tech, Estonian University of Life Science, Estonia. He will explain for us realization of sustainable food system by okay. Realization of sustainable food system by valorization of agri-food waste and byproduct in support of circular bioeconomy concepts. Rajev, the floor is yours.
Okay. Thank you, Chair. Good morning, everyone. Okay. For the next few minutes, I'll be talking about the activities that has been undertaken in our ERH in Valotech. We say ourselves as a valorization technology experts in the Baltic region. To expand this, it's the European Research Area Chair in Food Byproducts Valorization Technologies. So this was a new chair created with the funding received from the European Union way back in 2018. Before I go to the presentation, I just would like to show about Tartu city from where I come from. This is our beautiful, a very small and beautiful city with a lot of universities. 2 universities, of the universities are there. Of course, winters are very harsh, temperature going up to -27 to -34 degrees centigrade. So if you're planning to visit Tartu or Estonia, think about it. And of course, you can visit us in summer. That's the right time to come over. Okay, this has been declared as the European Capital of Culture for this 2024. A lot of activities happening in this small city. To tell about our ERH activities, I'll not be going to present in depth of the results generated by us from last 5 or 6 years, but rather I would like to show what are the activities that were done and what are the contribution of this ERA chain value tech to the regional economy. Of course, as I said, this was a new chair which was funded by EU Horizon project under 2020 program. And then we wanted to develop ourselves as a leading center of excellence in the region. And this chair was created mainly to meet the regional demand of reducing the environmental stress caused by food byproducts and waste that are being generated in the food industries. And then I took over the position, or rather I was elected as a full-time professor and a shareholder of this ERA chair in Valetech in 2019. Since then, we are working on a lot of aspects over here. So I'll be just briefly telling you about our contribution of ERH and Valetech to the academia, research and industry. First and foremost, these are some of the raw materials or the materials that we explored from the food processing industries, the waste and byproducts. It was from fish industry, fruits and vegetable processing industry, meat industries, and many other side streams were also explored. But due to lack of time, I'll not go in depth into this, all the activities, but I'll just highlight what are the major outcome, what we have generated. We explored a lot of raw materials from the food processing industry, apple pomace, sea buckthorn pomace. I didn't put the photo of the pomace here, rather because it just looks like an orange powder over there. So we worked on sea buckthorn pomace, apple pomace, berries, rhubarb, pumpkin peel waste, and we worked on gooseberry peel waste and hemp seed hull waste. These are some of the waste that has been created locally in the region. So we try to explore these raw materials, try to obtain value-added components for that with the biorefinery concept, and try to apply the concept of circular bioeconomy to get value addition. Some of the application part we studied was we tried to look into the potential applications of these value-added components that were explored and exploited or from this waste and byproducts of food industry. We try to look into developing functional food products, nutraceutical products, food preservatives from this waste and byproducts. We also looked into obtaining natural colorants, pigments from this waste and byproducts. We try to work on livestock feed, bioplastics, and other resources. So these things I'll be discussing in my next few slides. Okay, first and foremost, interesting factor we try to look into is trying to develop, extract natural pigments by using green extraction technologies like ultrasound, and then we use like other like supercritical carbon dioxide extraction for this extraction of these pigments. Our main aim was to see whether these natural colorants or pigments extracted from this waste and byproducts, which are of low cost, can it be a replacement for the colors that are being used in the food industries? Maybe, for example, we are also looking for a replacement in ice creams and bakery-based products. How these colors obtained from this waste can be used for developing natural colorants and replacing the synthetic one. A lot of good publications came out of this research work. We have also been working on winery waste. Of course, there was yesterday some speaker who was talking about cadmium and heavy toxic metals in this winery waste, but we are looking more into the bioactive components that can be obtained or the phytoconstituents that can be obtained from the winery waste or the vineyard pruning waste. We looked into shoots and we looked into the leaves and we tried to exploit and obtain a lot of bioactive compounds, mainly those of the polyphenolic compounds. Some interesting compounds were obtained, and then through chemometric assessment, we tried to look into the real picture behind these components. We also looked into the bioactivity of this extracts, what we obtained, and quite interesting results were generated, especially from the discarded leaves of the winery waste. So this was quite interesting for us. We also looked into validation of different genotypes of underutilized rowan berries. I'm not sure how many of people have seen these rowan berries, but some are really poisonous, which are not edible. Sometimes the kids think it is as a berry and they eat it, and there is like a lot of incidents happening. But there are also some rowan berries which are edible, which can be used and explored. So under our one of the sub-project team, we try to see and look into the value addition of these rowan berries and try to see what are the metabolites that can be present in that with proved bioactivity. Quite good results were obtained, and then we also tried to look into replacing this rowan berry pomace as an artificial preservative for preservation of meat. We use meatballs and try to incorporate the bioactive rich rowan berry pomace, and we got to know that there is shelf-life improvement at least by 4 weeks compared to the control samples. Some publications from our group over here. Going beyond, we also looked into producing bioplastics because, as I said, this work is going on in our lab from last 6 years. We also looked into bioplastic production from oil industry waste. Mainly, we used hemp seed hull and rapeseed hulls, and we tried to see and explore how this can be used for developing biodegradable bioplastics. Some interesting results were obtained for over there because we used mainly the heat pressing method to obtain the bioplastics. And now our next stage is looking into the picture of how can we develop this bioplastic as an eatable plastic, like eating the spoon or eating the plate, that concepts we are trying to apply. On the other note, we also try to look into the fish industry waste and byproducts. There are a lot of locally generated byproducts of fish industries like bones, skin, and hides from the local fish industries. So we tried to apply green technologies of extraction, and then we obtained gelatin from them. And this gelatin we try to use as a natural biopolymer to develop bioplastics. Of course, there is a slight modifications here and there done, but due to lack of time, I'm not going to go in depth into this. But overall, our view was to produce a sustainable bioplastics, which is cheap, low cost, reliable, and which can be applied for food industry applications. This was the work that has been carried out. Some publications over there, and few more is coming up in the next few months. And of course, I myself had a big grant on the EU grant related to using the fish industry byproducts for applications in pharmaceuticals and nutraceutical based research. If anyone of you are interested, later on we can have a discussion on this. How much time is required?
It's okay. You have around 2 minutes. It's okay.
Okay, I have maybe 3-4 slides. Okay, the basic concept is, okay, on one side, we are trying to develop new food products, or we are using the extracts of the waste and byproducts and trying to develop new food products for human consumption. Of course, most of you are from European Union, you know there is a lot of rules and regulations, and EC regulations are there, where we cannot directly use the extracted components directly into food applications, or which can be edible by humans, because we have to go through safety norms. So the idea was, okay, if you're not able to develop as a human food, can we take it as developing a livestock feed? Okay, that was also work which we carried out. One of my doctoral students is working on this. We tried to use hemp seed hull and sea buckthorn pomace and tried to develop the pellets out of it. We did some in vivo and in situ experiments also. In vitro digestibility experiments were done, and we found out that this was very valuable, low cost nutritious livestock feed can be developed by using the waste and byproducts of the food industries. So we are expanding our knowledge to vineyard waste also, like someone was yesterday querying on this. So we are also working on developing this livestock feed and pellets out of this winery yard waste also. Some interesting results are coming up there. Going one step ahead, most of you might be knowing what is the extracellular vesicle. So our concept was to go one step ahead. We try to extract the bioactive components from this waste and byproducts of the food industry, mainly from the fruit industry. We worked on apple pomace and potato peel waste, and we try to take these bioactive components and incorporate into the extracellular vesicles. And these extracellular vesicles, we are planning to put it back into the mammalian cells so that this can act as a carrier of natural bioactive components. So this work is being carried out, and which we got a lot of interesting results, especially from potato peel and from the apple pomace. That was about research. Coming to the next step, we are also contributing from last 4-5 years for academia, wherein we offer specialty teaching module for master student on valorization of food byproducts. And then we also are providing a new course on sustainable bioplastics and circular economy. Of course, this course has been offered both in Estonian and Erasmus students are taking the course. But as you see, I'm not basically from Estonia. I've been there from last 6 years. But of course, we also offer the teaching in English, and it's quite popular course among the Erasmus students who are coming from the international level. Of course, some of my collaborators are already sitting here, but it's okay. Going beyond, we are also undertaking a lot of training activities and reaching out to public, how best we can disseminate the knowledge generated from these valorization technologies or ERHL in Valotech to the industries. We offer a lot of webinars, seminars, conferences, And then we had a lot of winter school and summer schools in the last few weeks. And this was part of our activities to reach out to the public and to the industries. A lot of industrial efforts were there. We moved now beyond Baltics to the other countries also in the European Union. Of course, I do have a lot of collaborators in Italy also, but from other university. And we are also looking into partners from big international companies who are interested to come and join us to take up the lab generated data into the pilot scale. Okay. So future prospects is there in front of you. What are the economic benefits for local industry and other things need to be really carefully designed and well accepted. One thing most of the people are missing is the life cycle analysis that need to be really undertaken, and we are looking into that. And of course, we are also looking into the giving inputs to the policy. Of course, we cannot change the policy of the European Union, but how best this food industry waste and byproducts can be used and applied, and what are the new policies that can be recommended. We are also contributing, and I'm also part of few committees over there. And on another note, we are also supporting the new startup companies in the Baltic region and beyond Baltic region. This is some of the activities that are being undertaken. Okay, this one book of mine, which exclusively deals with whatever we have been talking from last 2 days. Everything is there in this single book of mine, which sold more than 15,000 copies in last 1 year. That's our rector in the middle. So if you have time to have access to this, I really suggest it's a big Bible of valorization technologies. So this book of mine sold almost 15,000 copies in 1 year. Some references. Of course, my talk cannot be ended without acknowledging my colleagues, collaborators. These are the group people who are working along with me, and I'm leading this team. And of course, thanks to the conference organizers and to the Cost Action Plan who sponsored my visit here. Thank you. And more information, you can get it in our website. Or if you want to discuss more, if there is a time constraint, we can always discuss this during the time break or a coffee break. Thank you so much.
Thank you for this interesting presentation. Really, let's open the floor for some question.
You also mentioned hemp as a
MSeed Hull.
MSeed. Did you? Have you considered PLA biopolymers?
Sorry.
Polylactic acid biopolymers from the polylactic acid based polymers.
Not yet. Actually, we didn't consider it because our view was totally into different angle actually, because we were focusing mainly on this waste and byproducts actually, as of now in the first stage. But in the second stage, we are also looking into biopolymers from the other sources. That is the second stage. We are taking up the work somewhere in the middle of June. But it's already there in our mind. We are also looking into microbial-based bioplastics to produce biopolymers, as well as we are looking into the other sources also. Okay. And LCB is one of it, actually.
Okay, thank you.
If you're interested, we can talk it later. Yeah. Thank you.
Thank you. Other question? So, thank you. Thank you very much.
Thanks a lot.
Okay, so we reached the last speaker of the session. I invite the Professor Abranco from the Hungarian University of Agriculture and Life Science in Hungary. The talk will be about the assessment of beneficial impacts of plant bioactives on macronutrient digestion by digestion simulation. Please.
Okay, thank you very much. Thank you for the organizers for giving me this opportunity to present here our work. And of course, I'm going to talk about agricultural byproducts. We well know the typical sources of plant origin, and I think it is important to mention also some resources of animal origin. However, I'm going to talk mainly about plant origin. And when we use it, one option for valorization is to extract valuable compounds from that, like fibers, pectin, other carbohydrates, protein, and also like bioactive phytochemicals like caffeine, vitamins, and primarily polyphenols. And once you extracted the polyphenols, there are many, many options for valorization, like preservation, natural preservatives, anti-browning agent, and one of the main areas is functional food production, and especially functional food ingredients. So it means ingredients that you add fortify foods, or you consume it with another regular food, I mean ingredient like this. And the key question is the function. What is the function if we fortify some foods? And what I'm going to talk about is how to influence or impact the macronutrient digestion, and I call beneficial influence, like in the case of fat, to reduce the digestibility of fat, in the case of protein to improve the digestibility, and in the case of carbohydrate also to reduce the digestibility. And we have to note it also that these extracts, what we typically want to use as a fortification agent, that are just partly purified. So it's not always we are 100% sure that which are the active compounds. So basically the aim of this work is to develop a comprehensive platform for testing these impacts of food ingredients on the digestion of macronutrients. This testing platform is suitable for nutritional research, and also it is suitable for as a test facility for functional food and functional food ingredients development. Our platform is basically based on two pillars. The first one is a digestion simulation. We actually use the well-known so-called InfoGest method. It's an in vitro digestion simulation. It's widespread. It first appeared roughly 10 years ago. And there is an updated version now. It's the 2.0 version, and it's a kind of static version. We use it for protein and lipid digestibility assessment. And there is also an updated version, which is called a semi-dynamic version of it. We use it for starch digestibility assessment. And in our particular case, the oral phase is in vivo, not in vitro. So this is one pillar. And just to outline how it works, it simulates the digestion in the mouth, in the stomach, and also in the small intestine. You add the appropriate enzymes, and you also add inorganic materials, and you want to mimic the physical and chemical conditions. And it should be noted that the InfoGest model does not contain the large intestine, so you cannot test the effects on the gut microbiota. And just to give you an idea, if you don't know this, how it looks like, I need to disappoint you. So there's no digestion robots. It's just regular laboratory operations like this. Okay. And the other pillar, I think, which is almost it has the same importance, is the analytical methods tailored to determine compounds in these ileal fluids. When we do protein digestibility, we can estimate the total in vitro protein digestibility, and more importantly, some widely used indicators of protein quality, like the digestible indispensable amino acid score, the DIAS, and the PDCAS, which is the protein digestibility corrected amino acid score. These are indicators of protein quality suggested by the FAO. And for that, of course, you need appropriate analytical methods based on amino acid analysis. For lipid digestibility, we can also estimate the so-called total in vitro lipid digestibility, how much of the ingested lipid is bioaccessible and ready to absorption. And we can also do more detailed studies based on fatty acid specific digestibility. It's a good mechanistic approach to understand what causes that impact actually. And also for that, you need appropriate analytical method tailored for that purpose. And finally, the starch digestibility. We can estimate some indicators of time-dependent digestibility with the well-established enzyme kit methods for rapidly digestible starch, slowly digestible starch, resistant starch, and total digestible starch, and so on. And we also have a kind of a new approach, what we are testing to provide an in vitro glycemic response curve to test the glycemic properties and how it changes if you add some additives. And for that also we need appropriate analytical methods. And I would like just to shortly give you two examples, recent examples on how we tested the method. It is a grapeseed powder, what we tested. It's a commercially available product for lipid digestibility. And what we can do with this method, since it's an in vitro method, of course, it has some limitation because it's not an in vivo test. However, it also has some advantages that you can mechanistically test what is going on and where you can find some room for improvement. So we use it with real food matrix. In this case, we use milk fat, like cream as a substrate for fat. And as you can see, we can do some dose response studies to estimate what is the lowest amount that is effective. Here it was 5%, and then you can see that there is a significant reduction in the digestible lipids. And what is interesting, if we talk about food, real food samples, if we just change the substrate, I mean the substrate like the source of fat from dairy fat to fat from beef, for example, we can expect different effects. So it means that, let's say, one inhibitor, lipase inhibitor containing extract, is effective for inhibiting the digestibility of one source of fat, but not for the other. And it might seem quite strange, but it should be kept in mind. And that's why if we do the fatty acid specific analysis, then we can get a better insight what is going on. And here, just without the details, what we concluded from that of course in dairy fat it contains much more triglycerides with short or medium chain fatty acids. And on the contrary, in fat, of course, we don't have it. We have the longer fatty acids. And the grape seed or the bioactives in grape seed most probably inhibit the pancreatic lipase, which has a kind of this preference for digesting these short and medium chain fatty acid containing triglycerides. And it means if you don't have it, this inhibition won't be manifested. So you can really tailor your product. What is it suitable for? And another short example, we tested sour cherry juice on the carbohydrate starch digestibility. We just prepared juice. It was with the pectin and everything was in there, so we didn't use enzymes for the preparation. And we tested the digestion using the approach of the ISO standard, which is originally for glycemic index testing of foods. So it means that we have to digest a reference food. In our case, it's a white bread, a standardized white bread, and we measure the sugar release at different time points. And then we tested along or co-consumed with the target compound containing the bioactives. We do all these time-dependent analyses. And here is just one result. As you can see, the yellow curve is the sugar release of the white bread, which is the reference for glycemic index if you measure it in vivo. And if you co-consume it with the sour cherry juice, there is a significant inhibition in the sugar release, which is a good thing if you want to reduce the postprandial sugar spikes after eating easily digestible carbohydrates. So in summary, if we think of valorization of agricultural byproducts, one possibility is to extract valuable compounds, but we always have to define what we think of valuable compounds. And in this case, we targeted the beneficial impact on macronutrient digestibility. And of course, it's one example, but I think for valorization, it's a key issue to provide some proof of concept that what is the target for valorization, these beneficial compounds. And I think this platform is one suitable pillar for that. And finally, I just want to mention that as a food science institute at the Hungarian University of Agriculture and Life Sciences, of course, and other groups, we have other competencies for providing evidence for these proof of concept studies like technofunctional properties, preservatives, shelf life improvement, colorant, and also sensory testing. So finally, I would like to thank for my colleagues and funding agencies, and thank you very much for your attention.
Thank you very much, Professor Abranco, for your presentation. We have a floor for a few questions, yes.
I want to ask you, have you tried high throughput analysis? Because it seems that you have lots of data. So chemometrics or high throughput analysis?
You mean chemometrics?
Characterization tests.
Yeah, for the compounds or the the sour cherry or
acids, for example, you are determining the fatty acids.
Yeah, then which not yet. So we have not tested too many entities. I mean, to worth doing a chemometric comparison, that what are the key components, if I understood well. Yeah. Okay.
Thank you.
Other questions? Okay, so thank you again. Thank you, everyone. And we are in perfect time for the coffee break, so we can see back all of you here in around 10:45.
All right, ladies and gentlemen, good morning again. Welcome back. I hope you enjoyed your coffee break. And without further ado, we have here the first presenter, my co-moderator, Zeynep Turgay from Migros, Turkey. And she will talk about prevention of food waste in retail industry. Floor is yours.
I would like to thank University of March for this excellent organization before starting my presentation. My name is Zeynep Turgay. I'm working in Migros, one of the biggest retail chain companies of Turkey. So I will make a presentation of how we can prevent food waste in retail industry. We cannot prevent food waste solitarily at any stage of food value chain. We have to have a holistic approach. We have to introduce systemic thinking to all agricultural industry. And why retailers are important, that they have both power and social responsibility and economical reasons in order to make such intervention stemming from the needs of sustainable development goals. Now, this is my agenda. First, we have to understand what food waste is. And in order to understand what the food waste means, we have to understand, okay, I will just wait for a moment because people are sitting down. Okay. Thank you. In order to understand food waste, we have to understand what is food waste a part of? It is a part of a bigger problem. It is food security. And we have to understand what is food security, how we can measure it, how food waste relates to other elements of food security, that is food quality, food safety, and food availability. And thereof, I will make an introduction of systemic innovation, how we can use innovation systemically to reduce food waste, and some examples of systemic innovation, including the projects we are doing in Migros. So this is my short bio. I am a chemical engineering with a computation and mathematical background. My expertise is on supply chain optimization and mainly mathematical model link and optimization. And for the last 10 years, I have been working for sustainable agriculture and food value chains. So I would like to introduce Migros. Migros is one of the largest food retail chains of company, and it is also accredited as an R&D center. So this is an interesting model of Turkish science and technology R&D centers. There is an R&D law, and according to this R&D law, the companies, large or small, who are investing in R&D studies are entitled some extra incentives. And these activities include patents, publications, and encouragement of our employees for master's or PhD education. And we make strong collaborations with universities and research institutes through Europe and also national ones. And we have been involved in 10 Horizon projects and lots of national funds for our responsibilities under being an R&D center. So the reason for this R&D incentives of Turkish Government of Science and Technology, Turkish Ministry of Science and Technology, is mainly the global problems that is summarized as Sustainable Development Goals by United Nations. This is the main reason for this R&D innovations. In order to encourage a strong bond between universities and the industry, we have to align ourselves first with this global agenda. We have to prioritize our R&D strategy and needs, and then carry out our activities accordingly. So, due to the Sustainable Development Goals, food security is the #2 problem. And food security, even though food waste is listed under 12th goal of responsible consumption and production, it mainly compromises the food security of globe. So 10% of the total population of world are faced to hunger. What is hunger is defined by United Nations, and 10% corresponds to people who go regularly hungry to bed. This is a regular condition of 10% of the people living in the world today. But when we look from another broader point of view, 1/3 of the world population does not have access to nutritious food. So they are instantly faced to food security problem. And from a larger point of view, all of us, almost all of us, are faced to food security problem because food systems are no longer sustainable and resilient, and we have to do something together for this problem. So, what does food security mean is enough food shall be available either by imports or by production. Food shall be accessible by everyone. Food shall be both nutritious and safe. And lastly, at all times means food shall be sustainable and resilient. So we have to establish sustainable and resilient food systems. How can we measure food security? We have two very important global indexes. One of them is Global Food Security Index, and the other one is Global Food Hunger Index. So let's look at the Global Hunger Index, which is not very a nice index because what it measures is undernourishment, child wasting, child stunting, child mortality. And according to this measurement, 1/3 of the population, global population, are faced to hunger. That is the rate, 33%. And food security index is a little bit different. It measures the capabilities of countries. And there are 4 important dimensions: food affordability, food availability, food quality and safety, and natural resources and resilience. Food affordability is simply that the food may be available or not, but if you have money and if you have means such as transportation, you can find food, you can buy food. You shall not produce this. And currently, most of the well-developed countries does not produce their own foods. They just purchase. There is another important parameter in food affordability. Suppose that there is no income inequality in the country. You can just simply set food safety net programs. That is, you distribute food freely to the ones who cannot buy themselves. That also solves the food affordability problem. Food availability is something related to your capacity of local production, nationwide production, and food safety and quality is associated to how food safety and quality systems you manage. Either you buy from outside, you import the food, or you can produce yourself. And natural resources and resilience is your long-term capacity. This is measured per country. When we look at these 2 indexes, we see that currently food availability does not have any effect on food security. That is, if you cannot produce food, you can buy this. But we know that this is no longer sustainable. So we have to work on food availability, and we have to cut food waste as far as possible, because in a decade, we may not find food for purchasing from outside. Okay, so what we can do is, according to this course, we have to invest on irrigation infrastructure, we have to have a food waste and loss program, and we have to improve dietary diversity and national nutritional quality in order to have a better global hunger index score. In the retail, traditional approach was discounts, but we all know that these discounts push people to waste at home. So promotions such as buy 2 and pay 1, which results in higher food waste rates at household consumption. So we no longer use these methods. We make some discounts. In a minute, I will tell how we can make it scientifically. But for the time being, we have to list our, if we list our initiatives, the followings are a strategic and systemic solution for food waste problem, which is related to food quality and which is also related to food security. So, first of all, we need Pareto improving solutions or Pareto improve policies, which means that we have to look at the system holistically. We have to consider all the stakeholders, and Pareto improvement means the total payoff shall be higher as a result, and none of the actors, none of the agents in this game theoretical system shall not be worsened. This is Pareto theorem. And according to this theorem, we are working on contracted agriculture encapsulating smart, fair agricultural practices. This is our first priority, because with contracted agriculture, you can produce the right quantity at the right amount. If you don't produce right quantity at the right place, with the desired quality, the food is exposed to being perished and wasted. And second approach is to promote local production. This is also important because CO2 emission is an important problem of globe. And promote high impact innovative agriculture practices and improve traditional food waste measures. So this is a new vertical agriculture system that I would like to share. And let's be more specific, and I would like to show some slides on how we improve our traditional food waste and approach. This is a discount project. At the end, Fernando Perez explained the project in detail scientifically, but how we do is we improved our discounts with this project. So our aim is to provide products with a sufficient shelf life so that consumers can consume the products at home with good quality. Not make discounts when about the product perishes and lose its appearance. Beforehand, we have to think about the shelf life at the consumption place. So reduce our food waste rate and don't compromise our revenue. So this is done by dynamic pricing. Dynamic pricing is traditionally used by airline companies. It's not only it considers the quality of the items, but also quantity of the items. So that if there is very available stock, very available inventory, you have to cut down the prices, even if it is a very expensive flight. Or if you have very less flights, very less inventory at your hand, you can increase the prices and sell a national ticket as expensive as thousands of euros. This is dynamic pricing. Of course, we cannot use this as is in food sector because we have social responsibilities and it will be penalized by our consumers accordingly. But we modified dynamic pricing, and with a combination of quantitative microbiology, we measured the shelf life of the items. And by making another measurement of the current inventory, we make discounts accordingly. So I don't have time for explaining the model, but this is a little bit explaining what we can do. We make discounts according to quality of the product without losing its appearance, before losing its appearance, with good quality still and good consumption time at home and at good prices. Okay. Sorry that I actually depleted my time. So
thank you very much, Zeynep. Maybe we still have time for one quick question or two. Are there any from the audience? Yes, just wait maybe a second for the microphone so everyone at home can hear you.
Thank you for your presentation, very nice. I'm curious about the model that you use to predict or to calculate the prices. Do you use dynamic programming or?
Yes, it's dynamic pricing. Dynamic pricing is based on dynamic programming theorem. So we use dynamic programming. Bellman equation, I showed the slides.
Okay, thank you.
Thank you.
So I would say thank you, Zeynep. I would pass to the next presentation.
Thank you, everyone. And our next presenter is the POSCI, Department of Post-Harvest Science, Agricultural Research Organization, the Volcani Institute, Israel, Induced Resistance in Fruit and Vegetables, the Physiological Effect.
Thank you. Thank you, Chairman, and thank you for the invitations. Thank you, Gianfranco, for the excellent work you have been doing in this organization that is not easy. In any case, our work is a description on induced resistance in harvest fruit and the possible problems that there might be. In improving this, prevention of disease development usually can be done by pre-harvest treatment with fungicide, post-harvest treatment with fungicide, and significant amount of work has been done on the pre- and post-harvest treatment to induce resistance. But in spite of all the problem, significant amount of decay is observed in the different produce. Because of that, it is important the type of work that has been done on pre-harvest and post-harvest induced resistance, because it's a new type of approach. If we are defined induced resistant, include all the different abiotic and biotic treatment that enhance defensive capacity developed by the plant to confer long-lasting protection during storage and shelf life. Actually, the question that we ask is, what are the natural mechanisms of resistance in the fruit? Are the same mechanism activated by induced resistance? And why there is no induced resistance in ripe fruit? Fruits have significant growth, are developing, and usually it's observed that in mature fruit, mature green fruit, the fruit is resistant to decay here against botrytis, while it becomes susceptible in ripe fruit. The question that we ask is it possible that simply the climacteric ripening directly triggers the increase in susceptibility to the disease and fungal invasion? And the answer is probably not, because susceptibility is also observed either in climacteric and non-climacteric senescing fruit. And this is what we see in climacteric fruit that with decay, and non-climacteric fruit as well with decay. The question is, what is the relation between fruit maturation, ripening, and disease? And this is some of the results I show you from previous work I have done, where I showed that Coleotrichum gliosporoides is germinating on the peel of avocado, produce apressoria, remain quiescent, and actually the apressoria breach the fruit cuticle and remain there for a lot of months. If we analyze the gene expression of this particular fungal penetration, we detect about 8,000 fungal genes that from this only 178 could be defined related to quiescent. But none of them have been shown to determine this, the activation of the infection. Actually, we go to a former type of work that we have done in the past. We found that several preformed compounds that are present in the peel and were found several years ago are significant modulating the development of the fungus in avocado. And actually, as the fruit is harvested and the fruit femurs start to decline, actually the concentration of this antifungal compound start to decline, and then symptoms are expressed as you see here. So actually, what is going on, there is an evolution of the resistance of the fruit at different ripening stages, where at the pre-harvest, the fruit is more responsive than at the post-harvest. What happens if we delay ripening? If we would delay ripening by just reducing the temperature, we delay the climacteric peak from 20 to 5 and to 0. And we can delay decay development, mostly in apples. We see that, or if we apply 1 MCP in mango, is it, and we see that there is a significant effect on delay of decay development. The question is this induced resistant or delay ripening? We are interested in a delay of ripening and maturation, and at the same time in an induction of resistance. So our first conclusion is that disease development is dependent on fruit ripening. Now, what is the basis of the resistance of unripe fruit? To show you this, I want to show a significant part of work that was done by John Labavich group and Barbara Blanco as well in the past in Davis, showing that mature green fruit are resistant to botrytis and red ripe are susceptible. If we analyze the common profile between resistance and susceptible cultivar, we saw a lot of things: receptor-like kinase, transcription factors, ethylene transcription factors, including ethylene response, development of stress response, including salicylic acid, ethylene and jasmonic acid pathway, the activation of several jasmonic acid biosynthetic process expression of flux, and several proteases and chitinase. What is interesting that the conclusion of all the work that was done by several authors is that the response in the resistant and susceptible interaction are similar, but still show different level of profile expression during fungal attack. So what it means that the ability to induce immune response does not appear compromised in susceptible fruit stage. This means that the genes are there. And the question is why the genes are not expressed during the susceptible stage. If so, we ask, why does the ripening mature fruit not show resistance and or induce resistance? So this is what we suggested together with Gianfranco, that there is actually in our paper we published in annual review recently, that there is an evolution of resistance of fruit and vegetable following induced resistance before and after a different ripening stage. The evolution shows a higher response before harvest that declines after harvest. And actually what we observed that the fruit resistant and induced process are dependent on the magnitude of the reactivity of the fruit. The reactivity is highest before and soon after harvest, where the reactivity of response of the fruit declines with the progress of ripening. What happened during maturation and ripening? A lot of things happening. Components of the plant immune system gradually lose either their effectiveness. The fruit shows reduction of defense hormone production, a reduction of signaling and downstream transcription response. Ripening process lead to cell wall breakdowns, simple sugar accumulation, changes in pH and secondary metabolite composition, and increased production and sensitivity of ethylene. This actually means that there are significant changes occurring during ripening that contribute to the induced susceptibility and mature fruit. But the question is, are all these changes actually contributing to susceptibility? And is it true? And I can tell you that it's not always true. If we analyze a significant part of the work that was done by John Labavich and Barbara Blanco, very interesting, where they compare the unripe and unripe situation of several mutants, the CNR, RIN, and all. They found very interesting observation. The colorless non-ripening fruit, that is a mutant that show altered cell wall architecture, show, as you see, susceptibility in unripe type of fruit. The RIN fruit mutants that are very interesting. The fruit shows significant tomato fruit. The fruit remains green, does not produce or ripen in response to ethylene, and you see they do not ripen and still show susceptibility. And the NOR mutant shows another interesting thing, is a mutant that where the fruit doesn't undergo most of the changes associated with ripening, and there is no symptom development. If we analyze all this, we got to our second conclusion that not all the factors occurring during ripening are involved in susceptibility. So you have fruits that have shown reached to the mature stage without any type of susceptibility. And this was confirmed by the significant work that Barbara showed yesterday, where she was able, and all his group, to do a CRISPR line, obtain a CRISPR line on the PG. You see in the middle, the PG line that was not actually infected by, was not affected by the resistance. And actually what she saw here, that the control and the CRISPR line that showing a tremendous increase in PG was significant susceptible. And only the CRISPR line with the PL was able to delay decay development. We can summarize that the fruit colonization is promoted by a decrease in preformed defenses and an increase in susceptibility factor during ripening. Now, what happened with the abiotic, with the induced resistance? Tremendous amount of work was reported by many of the people that are here, and examples showing different genes that are expressed, and the amount of people of treatments significant and increasing by month, with a lot of enzymes that are expressed. The question is are all those treatments modulating a specific limitation of fungal growth or a wide response of the whole fruit? And the answer is that mostly they are limiting fungal growth. A lot of treatments, I just give you some of them, some polylysin effect in decay, inhibiting decay development, phenylalanine inhibiting decay development by Noam Elkan, mostly giving an initial treatment with phenylalanine, or treatment with the BABA, beta-aminobutyric acid, that shows a significant inhibition of decay. Or the treatments applied to avocado that with different factors that you see that they show some physiological effects, but not clear determined, but a very significant effect on salicylic, jasmonic, PAL, LOX, and a lot of other enzymes. And for sure, the defense response elicited by chitosan and its derivative on the position of callose, lignin, formation of tylose, program cell, SAR, pathogenicity-related protein, and other factors. So the question is, what happened here? What happened is that very few treatments have been actually observing the effect of the induced resistance on respiration and ethylene production. Here, as you see, BABA is inhibiting the respiration and ethylene production, as well as chitosan that you see that 2% chitosan inhibit respiration. And this reached to my conclusion that induced resistance triggered physiological host response accumulation that limit fungal growth, yeah, but should delay at the same time the senescence and preserve the physiological response of the fruit. This will enhance a better response of the fruit. The general concept that we wanted to, with Gianfranco, is that it's very important to delay the ripening and senescence of the fruit. And for this, the research should be concentrated on delay of fruit maturation, where induced resistance can also modify the physiological effect of the fruit. And this is our future direction, as determined by a lot of the present work we observe here. And this fit the general work of Gianfranco, as well as the take-home message described by Lisa Corsten that fits the possibility of applying temperature and CA on the delay and as a part of the whole subject. Thank you. I'm sorry if I passed my time a little bit. And
thank you, Dov. So it was a very interesting presentation, but was a little bit longer. So I propose to everyone to save the questions for the breaks for later. And next up, we have Gonzalo Mejia from the Universidad de La Sabana, Colombia. He will talk about food loss and waste in central markets in Colombia, perspectives from our comparative study. Welcome, the floor is yours.
Thank you everybody for attending this presentation. I'm very glad to be here from long trip from Colombia. The title of my presentation is Sustainable Solutions for Food Loss and Waste Related to Problems, Case Studies in Colombia. My name is Gonzalo Mejia. I'm Associate Professor at the Faculty of Engineering of Universidad de La Sabana. I'm also co-director of the MIT Farol Lab, and I also belong to the UCTS Unisabana Center for Translational Science. I changed a little bit the topic of my presentation because we already have seen lots of the problems that we have with food loss and waste and related to food security and so on. But just to give you an example, in Colombia, we wasted 9.8 million tons of food every year, according to the National Planning Department. And typical Colombian wasted between 55 and 65 kilos of food per year, which is staggering. These figures are really staggering. However, this compares badly with other countries of the region. Colombia and Mexico, we waste around 34% of the fresh food, and Brazil and Argentina do a little bit better. In terms of type of products, fruits and vegetables and roots of tuber account for over 80% of the total waste, and most of the losses and waste occur at the agricultural production and distribution and retail stages, as we saw in the previous presentation, almost or over 60%. We have 13 central markets in Colombia, distributed mostly in the Andean region and on the Caribbean coast in the north of Colombia, that commercialize around 30,000 tons of food per day. So it's a big chunk of food. Just to mention, PostharvestAncona is in Bogotá, is the capital of the country, is the second largest wholesaler in Latin America and the most important in Colombia. They trade about 10,000 tons of food per day, which is a lot, receives 200,000 visitors per week, and unfortunately it wastes between 5 and 10 tons of food every day. So we have a lot of things to do. The reasons, the cause, roots, and effects, we already seen it throughout this conference. Poor planning, low investment in IT, in brick infrastructures, in transportation, and also the awareness of people. I'm not going to go deep into this because I want to show you more of my research. I'm going to show you how the, AI and operations research, or our tools, can be used in logistics and supply chain to reduce or mitigate the food loss and waste. The first case study is the improving the logistics of the Food Bank of Bogotá. The Food Bank of Bogotá plays an important role in addressing food insecurity and waste and reduce waste. It collects surplus food from supermarkets and other business, sorts them, and finally distributes over a network of over 600 organizations, basically NGOs organizations. And the problem that they have with the roots is big. This is a very, very combinatorial problem and so on. And the problem with the organization of these routes is that creates additional problems with the food loss and waste. And the food bank, of course, doesn't have the money to invest in a full commercial software. So we help them to develop a low cost, low maintenance, and easy to implement software tool. Basically, we designed the routes in 3 steps. Basically, the first step is clustering, which is an AI method. And then we decided to work on a operations research tool, which to solve the problem of routing. And finally, we assigned the routes to different days of the week. In the first step, we divided the Bogota in 4 zones: the northwest, central, and southwest, I guess. I remember exactly, I'm sorry. And this was done with an algorithm. And based on that, we use a software tool that is already available, it's open access, to create the routes. These are just examples. You can see the food bank and then the routes. But interesting is that this is a real case. This is currently under implementation. They are running the algorithms, and we have a potential savings in fuel and labor because the total distance is reduced in 24%. There are other issues, of course, like management is not just the algorithm, but this is a first step that we are proud to help the Food Bank of Bogota, and we have a very, very close relation with them. The second is a more strategic problem, which is the design of a network of food hubs. Yesterday we saw something about, or we heard something about food hubs in Colombia. This work was assessed and evaluated by FAO, and the Central Region of Colombia, which is an administrative office that organizes the food distribution and develops the master's plan and food supply chain in the Central Region of Colombia, which is in the middle of the Andes. Just to show you, this is the challenge. How can we bring fresh food from the countryside to cities in a sustainable way? Think that the Colombian region is very, very large, and it's not possible to bring all foods to the big cities just in the nearby zones of Bogota. So you have to bring them from far away. And currently, most of the producers, like in many emerging countries, are small farmers. Most of them have less than 3 hectares of land, and they rely on intermediation. That's the question I raised yesterday. So, of course, intermediation creates problems with handling food loss, food waste, and they don't create value, but add cost to the product. So we have the paradigm, we produce a lot, but the food is not accessible in the major cities, especially for vulnerable populations. So why there's intermediation in emerging countries? I don't know if somebody has ever thought about this. Basically, because it's the best alternative that we have. We haven't found another way to bring this food in a better way to the countryside, from the countryside to the cities. I think that these are isolated regions. We don't have like a trailer trucks that can go from these small plots, these small farms, and collect the food and bring to the cities. So there's a guy here, a guy there that has a truck, and then they collect the food from his neighbors, and then in a smaller town, in a bigger town, they are pooled, they are accumulated, and then they are brought to the bigger cities or bigger towns, and then to bigger cities. Sometimes the supply chain has 6 or 7 links, which is a lot. So we need a holistic approach, as we have already seen, that benefits all the stakeholders, and that includes the middlemen and, curiously, the consumers, because most of these plans, the end consumer is not considered. It's mostly for the producers, but not for the end consumers. So this is the proposal that we have presented to these organizations. The proposal of food hubs, especially a network of food hubs that use existing facilities in the countryside of Colombia, not close or not nearby the big cities, but close to the producers, because otherwise they won't go and sell their produce over there. So these are basically the reasons why we want to create this network of food hubs. And for this, we developed a mixed integer programming model. This is a mathematical tools that basically maximizes one or more objectives, assigning values to what they are called the decision variables. The main variables is which hubs should be open. This, as I said, these hubs are existing facilities. It's not like warehouses. It's maybe a basketball court or a football pitch that they can use in the weekends to consolidate the supply. Just to show you, I don't want to bore you with this, but this is the objective function. This is from the point of view of an eventual concession that will operate these food hubs. And these are the restrictions, the constraints of the program. Basically, we program this on a computer software, and then we run the simulations, and finally we find some results, and we can do some scenario analysis as well. Just to show you some of the results, how the transportation cost, how the variable cost of operation, and how the emissions as well are reduced by using this approach. This is a visualization of the solution that we are proposing. The yellow dots are the hubs, and the red are the connections with the farmers. This is the distribution of the produce that are sold or commercialized through these hubs, depending on the region where they are located. And some of the results are basically this. The strategy can be sustainable. However, as in any solution of this type, politics play a major role, and the government changes, so you have to basically start over. I'm sorry, but I want to show you some of the pictures that we have done, and this is my team, and this is it.
Thank you very much.
Thank you very much. So this is my email. Please write me. I'm happy to collaborate with all you guys.
And are there any questions? One over there, just a second, the microphone is coming. Yeah.
Thank you. It was a good presentation. I would like to, I was interested in your last slide, actually. You said politics plays a big role in your country. So how does it affect this type of practically applicable work? Can you elaborate something on this?
Yeah, well, the thing is, we started developing this model in the previous government. So the new government starts basically over. So people change in the organization, so you have to contact them again. And maybe the new government has new plans. And so we have to work over that again and again. And yeah, politics. You need to do lots of lobbying and stuff.
Acceptable one for your region.
Yeah.
So if they're not accepting your ideas, then every time it changes, then new things have to come up.
Yeah, well,
so what is the solution for this? Like as a researcher, as a scientist, I was more interested to look into the solutions. What would be the solutions, future solutions? Like, of course, whatever you presented is all practically applicable things. But if you think on changing government and policies and other stuffs, so what would be your personal view on this? like sometimes we also come across these type of situations in our place also.
Mhm.
So I'm just looking into that, your experience of handling this stuff. So what do you think from your perspective?
Yeah,
Or-
well, we have to be well connected. At the beginning, there's lots of talk about intermediation, and basically I wanted to test if the model could work. And the results, we changed the parameters and we changed the scenarios, and it works. Now, and then at the beginning, we evaluated this with the policymakers and with the FAO, and everything went well. But then the government changed, and then you have to people change and so on. So
we have a question over there.
Thank you for your presentation. I am not in this field, but I wonder, some of the methods and applications that you use in this scenario in Colombia, can it be extrapolated to different regions? And like, what is your advice for people that will be starting this type of solution or for strategies in a different place? What is like your guide?
yeah, but actually the novelty of this approach is that it's for emerging countries in which there's lots of intermediation. Because like in other countries, like a big landowner that can bring their products directly from the countryside to the city, this model won't work. But in places where there's lots of fragmented farmers, fragmented production, you need to, this model can work. So I think in emerging countries, but I don't know the realities of other continents, but in Latin America, it can work. Actually, the idea is not new at all, but this is like a more focused with the numbers and with something that supports, like a mathematical model that supports the ideas.
Thank you. Was there anything else from the audience? No. So thank you, Gonzalo.
Thank you.
So last speaker for this part is Elena Battini-Sommes from Istanbul Bilgi University in Turkey, and she will talk about smart solutions for waste prevention with case study on fruit and vegetables. Welcome, Elena.
Thank you. Thank you. Good morning to everyone. Thanks for having me here. Yeah, my presentation is going to be divided in 3 parts. The first 2 slides, I introduce myself and my job, because I think I'm the only computer engineer in this conference, just to give you an idea what I'm doing and why I believe it's important, actually, my job in this, also to be applied in this field. In the second part of the presentation, I will show the current study done about assessment of the degree of freshness of fruit and vegetable. In the third part of the presentation, I will speak about a project which is in my mind to reduce food waste. I plan to implement it in Turkey, but any other developing country, it can be applied. So, my name is Elena Battini-Sommes. I work as associate professor at Istanbul Bilgi University in the Department of Computer Engineering. This is my background. I get undergrad from the University of Pisa, Computing Science. Then I went to England. I did a master in computing science. And then I moved to Turkey, and I did the PhD. So you can see that every degree I changed country and language, and that was challenging, especially the last one in Turkish language, quite challenging. Anyway, my research topic is digital image processing, machine learning, and I work also with human-computer interaction that is not interesting for this conference. Now, what does it mean, digital image processing plus machine learning? It means that you give me an image and I retrieve information. I get information out of this image. So, for example, in my PhD, I was working with images of faces, and then I work with identity recognition or emotion recognition. If you give me the image of food, you see a dish of food, and then what I have to do with this picture. So first of all, I make segmentation. So I write algorithm to have segmentation. Segmentation means that the algorithm is telling me where is the food inside the image. In this case, we are going to see the green area. There is one type of food, and the pinkish area, there is a different type of food. Having done segmentation in a proper way, then there is a classification. Classification means give a label, a name to the type of food. So I pay particular attention to this picture because I will come back to this subject later. Then obviously I work with a lot of other type of images. So for traffic sign classification, iris recognition, Turkish Sign Language recognition, a lot of things. Right. So this is my sabbatical here. So this year I don't teach, I don't have administration job, I just can make research. So I decided I wanted to work on project, and many thanks to Professor Romanazzi accept me to this project. And also in parallel, I'm planning to write my own project, right? So we know this cost action 22134. And for what is concerning the second point, what I thought, okay, I want to write a project, obviously must be an active, hot research topic. So I found this report of the United Nations speaking about the 17 SDG, and I found goal 12, which ensures sustainable consumption and production pattern. It includes 12.3, which aims to halve per capita global food waste at the retail and consumer level by 2030. So I thought, okay, I can work on that because, as I will tell you now, my idea, okay, I can work with images of food. Right. So in order to be in sabbatical in Turkey, you need to get this invitation letter from professor abroad. I have an invitation letter from the professor of the University of Florence, another professor, University of Barcelona. They have my research. They do, again, a digital image and deep learning, machine learning. I am already in contact with İstaç, is the firm, Turkish firm responsible to collecting rubbish in Istanbul. And I'm trying to contact Italian firms, equivalent Italian firms, to run my project that I will speak at the last, is the third part of the presentation. I will introduce you the project. And if you are interested, if you have other idea, if you want to be part of the project, you are more than welcome. Now, I mean, as a second part of the presentation, I will show you what I did until now related to the fresh fruit and vegetable, because this is the aim of this project. Okay, so I'm currently supervising a group of students at Istanbul Bilgi University. The aim is to improve classification algorithm capable of recognizing the degree of freshness of fruit and vegetable. Now, this algorithm, if they work in a proper way, okay, they can be implemented like in a smart container or intelligent fridge. Now, you know, there is this Internet of Things coming on. So Internet of Things means that we will be able soon to connect all our electronic device. And I'm thinking to this intelligent fridge, right? So I am in the supermarket. I don't remember if I have the apple or the eggs in the fridge. I'm querying the fridge. So do I have apple? And the fridge will answer me, yes, you have 3 apples or any other type of things. Now, in the same way, okay, if the fridge, because inside the fridge, we're going to put the camera, right? The fridge can tell me, be careful because the tomato is getting off, or be careful because this other type of fruit and vegetable will get off. So the main idea is that if we we need to improve algorithms. Nowadays, they are not capable to do it in a proper way, but we need to write algorithms, improve them in order to have this capability. All right, so how do we do it? We need databases. So a lot of picture, and we give to the algorithm, this picture. Normally, when you have a database, 80% of the picture, they are used for training and 20% for testing. So we find, unfortunately, only one database about fruit and vegetable. And here in this slide, you can see some of the pictures. So we have like tomato and we have a fresh tomato, medium tomato, and rotten tomato, and the same for the others. Now, this database is quite a little database. Oh my goodness, sorry. Is a little database. Here, in the next slide, I describe it in detail. We have only 11 items. Every row of the table is an item. And at the end, you can see that I have like 20,000 images for every class. I mean, for the fresh class, the medium class, and the rotten class. So, but I have only like 4,000 images for fresh apple. So it's a very little database. And it's also not realistic, because if you look at this picture here, there is only one tomato. So it's very easy, basically, to work with this type of picture. There are not realistic picture. All right. Anyway, our student, my student, okay, they're very good, and they already beat the performance of the benchmark paper. So we have this paper, they introduced the database, and they say which is their best performance in the classification task. And we already run our algorithm, we have a better performance. Now, my question to you is, okay, what shall I ask the student to do for the second semester? So they can obviously try to improve the current performance. They can try different type of algorithm on the same database. It would be much better to have to work with, to challenge a more difficult database. But there is, I mean, I couldn't find it. We couldn't find. If you have a database of a fruit and vegetable, fresh and rotten, and you can share with us, it would be very nice. Or if this database does not exist, I believe that we need to build it. And okay, it is obviously time consuming and whatever. So what I did then, I searched in the literature review other paper, other previous work done related to fruit and vegetable. Now this paper here, they do something very similar to us. They have original database of apple. Okay, they pre-process the image, and then at the end they make classification. At the last, you can see if this is the input image, the correct output is supposed to be a normal apple. If it gives rotten apple as output, then the algorithm is not working well. Other possibility is to create agromedical expert system. In this paper, they work with jackfruit disease. So let's look at the second column where I have a leaf spot. In the leaf spot, you see that, okay, there is a problem with this leaf, all right? So the algorithm, on the top row, you see the manual. So the problem is that to create this database and to make segmentation, basically, it has to be done before manually by human being, and it's quite time consuming. So the top row is called ground truth, is the exact manual segmentation. The bottom row is the result of the algorithm. Okay, so we need to have, if you are interested in this type of research, we need like 10,000 images. They must be segmented manually, and then we train our algorithm. I'm very late. So this is other possible implementation. So here we have a robot going around in the greenhouse, getting picture, out of the picture extracting the tomato part. This is another possible application that we can do as a computer engineering. So here in this case, we have a drone fly on the field, you get the picture, out of the picture, you return, okay, the algorithm, and the return is telling me if there are some disease in the leaves. But, okay, I came back now to the third part of the presentation. Unfortunately, my time is over, so I will be very, very quick. So in Turkey, there is not this separation of waste. So my idea is to implement in Turkey only food, not food. So ask people to separate the food from the not food. Then the not food is going to be separated automatic by robotic arms. There are already some robotic arms. And the food is going to be quantified by intelligent rubbish bin. Now, intelligent rubbish bin, you see this is a picture. The rubbish bin is on the top of the scale. And before putting in the rubbish, the leftover in the plate, there is the camera. So out of the camera, basically, so thanks to the camera, we have a picture of the leftover in the plate. And then with segmentation, this is my last slide, just to remember you, which is segmentation, the algorithm will understand which is the food that you put in the rubbish, considering the change of weight before and after you throw the waste in the rubbish bin. He can also find out the quantity of the food that you put in the rubbish, at the end of the day, it's going to tell you, to the chef of the restaurant, for example, okay, today you put in a rubbish 20 kilo of bread, or I don't know, whatever is the material. So knowing what you put in a rubbish, obviously you can change the menu. And these things, this intelligent rubbish bin is going to be implemented before in the restaurant, in the hospital, in the school, and then later in every house. But we need to create a database. We have algorithm, we know how to run algorithm, is good, but we need to create a lot of database. So if anyone is interested in this type of application, you can contact me anytime. This is the reference and the question.
Thank you very much.
Okay.
So are there any questions for Elena?
Thank you for your presentation. I have a question is, you mentioned the intelligent fridge, but you say, I have, say, a box of tomatoes, but those who rot first are the ones that are in the bottom. So if, the first tomatoes that rot are the ones that are in the bottom of the box. So they need to be accessible to the camera. But my question is, are there any other methods to detect?
No, that's true. I mean, this database, which I show you, it is not realistic neither, because you see that you have tomato or apple, whatever, you have the fresh apple or just one tomato. So we need, if you are interested in this field, to create more realistic database. So to get, for example, the picture of the complete chest of the tomato. And no, if you cannot look, with images, if you cannot look, obviously you don't detect it. So the ideal case is to put it, but in the fridge, okay, if you consider the idea of intelligent fridge, we are not going to have only camera, but we are going to have other type of sensors. So like smell sensor or any other type. So and this is actually, I spoke about this project with to the Ariston firm, which is a firm in Turkey producing fridge, and they do have a research department, and they invite me and they say, okay, they are actually working on this idea of intelligent fridge. The problem is very far away from Istanbul, so I couldn't do it. But if anyone here is interested in this idea, my idea is to buy a little fridge to keep in our university, and together with electronic department, we are going to put different type of sensor, not only the camera, but also, for example, the smell sensor and other type of sensor, which will sort it out the problem.
Thank you very much.
Thank you.
Is there any other question from the audience over there?
Thanks. Quite interesting work actually for the future. I also have been working on artificial intelligence and how this can be applied for, or maybe in short, I can say digitalization for management of food industry waste and byproducts. That's also we are working on as of now. But I am more interested to look into your inputs. How reliable would be the data what you generate from all these things? Because at the end of the day, because you are talking about a small lab scale structure and how it works, when you look into the broader picture on a pilot scale, how do you think it will work out? And what would be the repeatability and reliability of the data you generated? Because you compared your work with some POW that are some previously generated one.
Yeah, nowadays.
So I just wanted to know your inputs.
The importance of collecting picture, real life picture, not is very important. I mean, this is a very high importance. Obviously, it will increase the performance of the algorithm, and it will increase the performance in real life. Okay, so that's very important. But because we are working in this sector, if we have interest, if we start the project, I think, okay, we will be able to select also to take a real picture. So I think it's going to be reliable, because if you work with artificial intelligence, you know that now this deep learning algorithm really make miracle. It is a big investment. I'm saying an automatic system compared with human labor, has the advantage that it will work 7/24. It is free of charge. Obviously, you need to invest at the beginning and to have a good performance, and then only the maintenance. But it's gonna solve a lot of problem. I mean, this is the future actually. And as I said before, I see that for fruit and vegetable there is basically nothing. I mean, very little. So we need to work a lot on this field. And I hope, okay, with your help, with your support. Okay.
Thank you very much.
You're welcome.
I don't know if we still have time for one last question. It's over there. Yeah, I think, yes, I think so. Sorry.
Wonderful project idea and something that comes out of the new era, the new age. I was thinking what kind of sensors or what kind of physicochemical properties you can attach to this system in order to treat your model besides the visual with some real data, so you can correlate and say, all right, this is a picture and has this kind of models, this kind of results. So you can better treat your model. And can you tell us some sensor or some, because you said about smelling and things like that?
Yes, but this is just my idea. I'm not a chemical engineering and I don't. So if you are interested in this project, I mean, we have actually in Bilgi a bioinformatics department and they're very active too. So they will suggest my idea. Okay, if I'm alone, I will cooperate with them and asking them again, the same for the electrical electronic department for other type of sensors. So my original idea, if I have the possibility to create this smart fridge, is to cooperate with electrical electronic and my bioinformatics department in Bilgi. But as I said, every one of you is interested in this idea. Maybe you can give me good input, which type of chemical sensor to use in the fridge. I don't know because I'm not in the field. So to support images, basically.
Thank you. So if there are further questions, I suggest to take them to Elena with the break. So I'd like to thank all the speakers of this part, and we will move on to the next session. Thank you.
Okay, so let's continue with the presentation of Working Group 6, which is about networking, dissemination, communication, and transfer of knowledge. Our first presenter will be Magdalena Bialina-Grajewska from Poland. And the title of the presentation is Communicative Side of Food Loss and Waste Management.
Good morning, everyone. First, I would like to say that I'm very happy that I can be with you today. So thank you very much for inviting me to take part in this interesting discussion. To introduce myself, I'm a linguist and I'm an economist. So that's why in my research, I try to combine these two areas of studies. In my scientific studies, I focus on communication, on business communication, on food communication. Also, since I'm a linguist, I teach translation, maybe economic translation. So that's my background. So I would like to say why I'm here and why I'm in this particular group devoted to dissemination and communication. Today, I would like to speak very briefly about certain areas of communication that, in my opinion, are very important in our discussion on food loss and waste management. In the next few minutes, I will focus on the communicative side of food loss and waste management. So why we should take into account communication in our current discussion. Also, we should not forget about the role of effective communication in sustainable nutrition. So it's also important to highlight that we should pay attention to communication. We should pay attention to different mode channels of communication, since our communication should take into account different stakeholders, different people participating in the current discussion. Also, I know that I don't have enough time, but I would like just to state very briefly about different types of communication that can be used in our discussion on food loss and waste management. So when we look at the modern food sector from the perspective of communication, because as we know here in our discussion, we represent different disciplines, we present different points of view. So in my research, I just want to focus on how we communicate the most important ideas related to the food sector. So when we look at different articles, at different books related to communication, we can see that there are some, if I can say, disciplines, some areas that are more visible than the other ones. I listed them here in my presentation. So generally speaking, you can find discussion related to risk communication, marketing communication, benefit communication, and sustainability communication. And I just want to stress that the list, of course, can be longer. I just selected the ones that, in my opinion, are important for the current discussion. Regarding risk communication, as you can see, when you look at the research from Landgren and McMakin, you can see that risk communication is very often associated with such types of communication as care communication, consensus communication, and crisis communication. Care communication, because it's connected with the lifestyle of different people, and we should know it in order to adjust risk messages. Consensus communication, since it's connected with different opinions, but also anxieties and beliefs of different stakeholders. And crisis communication, since we should take into account the culture of target audience when we create and disseminate different messages related to crisis. And that's why in one of my previous research, because in the past I was interested in foodborne diseases from the perspective of communication. So I also researched such areas as food care communication, so different risks connected to food consumption, selection, ways of preparing food and places of consumption. Also, I focused on food consensus communication, different opinions, knowledge, and fears connected with food, and also on food crisis communication, the culture of a target audience and communicative information on food crisis. So as you can see, I took the previous categorization and I discussed it according to my research areas. Regarding the topics that you can find in literature devoted to food risk communication, as you can see, there are many different topics. Among them, you can find discussion on food irradiation, genetically modified food, food recall, food contamination, foodborne diseases, food allergies, and of course, the one that is of crucial interest to us and my research group in our project, namely the food waste. And as I said in my introductory part, you can see the communication related to food loss and waste management from the perspective of different types of communication. One of them is, of course, marketing communication, as you can see in the definition taken from the dictionary. Marketing communication is defined, let me quote, a piece of advertising that a company uses to encourage people to buy a product or service. That is the definition that we all know, but we should also remember that encouraging people to buy certain things is also connected with establishing relations with customers. And that's why this type of communication can be very important in discussing the ideas crucial in our project. The next one, which is, I think it's pretty obvious, is connected with sustainability. So generally, communication related to sustainability is, as you can see in the definition provided on the slide, is connected with different discussion related to ecological, economic, and social sphere of our life. So according to Godeman and Mikkelsen, we can find such topics as climate change, biodiversity, consumption, production, and mobility. So that's why this concept is very broad and can be also taken into account when we discuss communication. Also, very often in literature, you can find the interest in benefit communication. And when I researched the articles devoted to the topic, you can find mainly, so far, two research areas. So that's the benefit communication used in sales. And as you can see on the slide, it's connected with showing the customer the perspective that makes the product more interesting, more competitive than the other one. So for example, you stress technical features or another features that are important. Of course, you also have benefit communication used in employee-employer relations. So it's mainly showing that the place when work works is very important and very beneficial for the person. What we also have here, and what we should not forget in our discussion, is that we can have different types of communication. So communication devoted to food loss and waste management can be studied, as you can see, from many different spheres, because we can focus on verbal communication, which is, in my opinion, the most obvious ones, but we should not forget about the nonverbal one, the use of, for example, pictures, the use of different forms of pictorial representation. Also, we have literal communication, and we have the symbolic one, so the one that is also crucial. Since with the growing role of modern technology, we communicate more and more online. So also we should remember that communication can be discussed taking into account the fact that it's online or offline. Yeah, so there are these different areas that can be studied as far as communication is concerned. And I know that I don't have a lot of time, so I just wanted to show that I'm particular as a linguist. I'm interested in metaphors, so in the symbolic, let's say, layer, because in my opinion, as Lakoff and Turner say, metaphors are crucial when we want to perceive the reality. Also, some scholars, such as, for example, Brown, underline that when we use metaphors, we can understand new concepts by using familiar domains. So it can be especially useful when we discuss new topics related to food loss and waste management. We use some metaphors that are known to many people, and that's why new concepts can be easier understood. And also, another important issue, as you can see, is stressed by Bergman, who says that we use metaphors in novel domains which lack a certain type of vocabulary. And that was the case, for example, in the language of economics, which I study. When there were new concepts, they were very often described or created by using metaphorical language, and it proved to be very useful in the discussion on novel ideas. Also, just to summarize the discussion on metaphors, we have here Tilly, who states that when we use metaphors, we can describe very complicated issues by using just few words. So I just want to highlight that in my opinion, metaphors can be also a very interesting tool in studying communication. Okay, just to summarize, I just want to say that, in my opinion, communication is very important in the discussion on food loss and waste management. As I wanted to present during my short presentation, the topic, as you can see, is very broad and encompasses many different issues. And that's why I think that it can be an interesting starting point, maybe for some common research in the future. Also, my second important idea is that we should remember that communication can take various forms, involve different stakeholders, and that's why communication should be also let's say not only discussed but also taught, since it's a topic that is changing and it requires a new knowledge also from our side, taking into account, for example, as I have said, the growing role of online communication. Okay, here are my references that were connected to communication, food risk communication, also to metaphors. And just to finish my presentation, I would like to thank you very much for your kind attention and being with me here today during the conference. Thank you very much.
Thank you, Magdalena, for your interesting presentation. We have time for a short question. Do you have a question? No? Okay. Thank you very much.
Thank you very much.
The next presenter will be Akraf Ammar from Germany. Mediate for All approach to support food waste prevention.
Buongiorno, everyone. So first of all, thank you very much for the COST committee and core group to invite me for this interesting conference. So to introduce myself, I'm Ashraf Ammar, originally from Tunisia and actually senior researcher in Germany. I'm a sports scientist, but I'm here with you because I'm a fan of multidisciplinary and holistic approach in research and collaboration. So I did research in physical activity, movement and well-being, and recently also in public health. During the COVID-19 pandemic, I have launched initiative international research to understand the public behavior and to determine and identify possible factor which has been in the origin of the psychosocial strain in the public. So this approach, or this multidisciplinary approach and the holistic approach, allowed me also to apply for the PRIMA project with the section of food, and we have been successful to have our project approved, and it's an ongoing project. So I will try to explain how such project can also support food waste prevention. So the main goal of the project is to support the sustainable transition toward a healthy and eco-friendly agri-food system with a main focus on Mediterranean diet and Mediterranean lifestyle in modern society. The project includes 10 partners from eight countries, and as you can see, they have different expertise in food, in nutrition, in food technology, computer science, biopackaging, and health and medicine. So let's start with understanding the impact which the food have. So food, as you know, have impact on your health, and the impact will depend on the dietary pattern which you are following. So if you are following more Western-like diets, there is more possibility to have or to develop cardiovascular disease, diabetes and cancer, as well as mental disorder. While when you follow protective and prudent-like diets, you are more or you are more in the protective and the prevention diet pattern. The food has not only an impact on our health, but also it has impact on the environment, and we know that more than the quarter of global emission came from food and particularly from animal products. So all of us agree that there is a pandemic global problems. In one side, we have more than a third of the population with overweight, 13% with obesity, while we have also people with food insecurity and who are undernourished. And in the environment part, we have more than or around quarter of greenhouse gas emission come from the food sector. The high-level panel of experts on food security and nutrition has proposed a food system interaction. It includes many drivers from biophysical and innovation technology to political and economical driver, as well as socio-cultural driver and demographic driver. They are connected with different items from the food system, like the food supply chain, food environment, consumer behavior, and the dietary pattern. And as you can see, the consumer behavior is in the center of this interaction between the different items. And this is why in our project, we try to understand first the consumer behavior and to focus on changing consumer behavior to be able to change or to have an impact on the other items of the food system. So first of all, we try to understand the consumer behavior, and we found that due to the modern society, most of the people are shifting toward the ultra-processed food, and that's this ultra-processed food already contribute to more than the 50% of nutrient intake in Euro-Mediterranean country. So ultra-processed food and minimally processed food, what is the difference? There is a NOVA classification. And with the NOVA classification, we can see group 1, who is the intra-processed or minimally processed food. They have positive impact on the health and very low impact on the environment, while the group 4, which is the ultra-processed food, has a negative and harmful impact on the health. It increases many risk factors of cardiovascular disease and diabetes 2 and depression, etc. And also it has a high impact on the environment with its extended food supply chain, the increased waste, manufacturing, and the use of extensive packaging. However, despite this harmful effect, the people are shifting toward this harmful dietary pattern. And the reason were the lack of awareness between the people, as well as the modern society trend. And this is because of the emergence of industrial food system and transnational corporation, which offer convenient, highly profitable, widely available, and easy to consume food in a very attractive packaging and supported by intensive marketing and advertisement. So the project is focusing on enable the transition from ultra-processed food to minimally processed food by first increasing the awareness among the people of all age, and secondly, by promoting the convenience and the competitiveness of the minimally processed food. And we have chosen the Mediterranean diet because it's the most evident eating pattern that promote health, longevity, while also saving water, energy, and reducing greenhouse and conserving the land. And you can see that the Mediterranean diet pyramid include not only food aspect, but there is also social dimension and physical activity dimension. And for those who have attended the last night dinner, it was really a very perfect example of the Mediterranean food pyramid. So the concept of our project, first of all, in the top, we will try to understand consumer behavior and to identify the factor which derive the low adherence to Mediterranean diets, as well as to understand the barrier against the adherence to Mediterranean diet. And this is through a multi-center survey-based study. Based on the data which will be collected, we will go to modernize and improve existing Mediterranean and traditional recipes. We will try to make these recipes more modern. That means less time consuming, highly nutritional, with high antioxidant activity, and mainly minimally processed. Then if we have recipes, if we have food, we need also packaging, and we will try to develop at least 3 types of packaging for ready to eat, ready to heat, and long life food. and it will be based on bioactive and eco-friendly products. We then would like to collect all this product as well as the producer provider from different countries in Mediterranean database, and at the same time to launch different awareness campaign to regarding the Mediterranean diet, the healthy and environment aspect, and regarding the technology or innovation part of the project. We want to develop a Mediterranean, so-called Mediterranean integrative platform, in which we will invite the different supplier with a focus on mid and small size farmer, and to create a network between the consumer and the producer to allow or to support the farm to fork strategy. And then we have also thought about developing a smart coach, which will be a companion for the people and which will allow to deliver some tailored intervention for the people based on their profile. If we success to develop this product, we program to have a multi-center intervention case study in which we will test and validate the efficacy of the application prototype. So these are our work package, expected impact, and we start already to launch our survey and to select the potential traditional made recipes which can be improved in terms of nutritional value and antioxidant capacity. This is the design of the electronic integrative platform, which will include farmer, producer, as well as the different products. And this is our approach, how to develop the decision support system for the mobile apps or the coach. So the idea is that we have to profile or make a profile for all users to understand their objective. For example, for people who have overweight, so the objective will be to reduce the weight. So we will focus on giving different scenario with a balance between energy expenditure and energy intake in favor of energy expenditure. And we try to take also into consideration the preference of the people, if they are vegan or vegetarian, or if they have some religious barrier against some meat, etc. So this is the concept of the apps, and we start already to develop the profiling part of the apps. And I want to summarize with the contribution of the Made Diet for All approach in the prevention of food waste. So we are supporting first the farm-to-fork strategy with this integrative platform, and also with organizing farm-to-fork market and making awareness in different countries about the importance of such a market. We are trying to tackle the transition toward the ultra-processed food, and ultra-processed food mean extended food supply chain and mean food waste. And we are trying to improve the availability and convenience of the minimally processed food, the Mediterranean food, and to valorize the food waste, especially in the work package related to the bio-based packaging, in which we want to use by product. Then we try to increase the public awareness with reduce food waste and to know about the health and environmental impacts, and to promote the social dimension of the food system by creating social inclusion platform and organizing different basic lifestyle activity. These are some types for more sustainable diets. This is our ultimate goals, to transform the consumer behavior as well as the agri-food system toward a more sustainable and health system. And finally, this is the QR code for our survey, and I'm kindly asking you to take a picture of the QR code and to help us when you have time, please, to fill in the survey to help understanding the consumer behavior in the European and Mediterranean country. And thank you for your attention.
Thank you, Akrab, for your presentation. We have time for a quick question. One question. Okay, thank you. Our final presenter will be Bakir Ayırdis from Turkey. Scientific studies on food waste in Turkey.
Ladies and gentlemen, welcome to my presentation, and which is about scientific studies on food waste in Turkey. Let me define myself. I am working on assistant professor in Yozgat Bozok University in the middle of the Turkey. I don't want to define you food waste too much to take your time, not to take your time. But in Turkey and European Union, food waste is a big problem, and some researchers define as a catastrophe, disaster, and a big problem in the worldwide. But in Turkey, at least 30% food were lost. We are using. But we are not using anything for the losses. My research is 2 steps. I will define you. For example, the first step is a review of the Turkish research, and the other is making a prediction with 5 years about West Turkey and the European Union for per capita. In Turkey, we have worked with 87 studies, 87 research, and among these, 69 were published in local scientific journals, and 18 were published in the Science Station Index. Analyses have been conducted on the Turkish Statistical Institute for time series. We worked with 23 time series, and the material methods. I want to define a little time. In the prediction, we are using 3 steps. For example, 3 steps: mean absolute percentage error, mean absolute deviation, and mean squared deviation. When the mean squared deviation is the lowest value, we can choose the true one for our prediction. This is our equation from for our predictions, and we worked with 4 predictions, and this is our models and equations. In findings, in Turkey, scientific studies conducted exhibit a degree of the overlap with each other, and almost 85 conducted studies are based on survey methodologies in Turkey, and the other steps of our research. We worked with waste generated for per capita with kilograms, and I will show you one of our findings for the analysis. As we can see, we focused on quadratic model, and we are waiting. I will show you a graph. We are waiting a rising on west. We are waiting rising. As you can see, our prediction graph, and the blue lines are actual values. Red ones are fits values, and green ones is our forecast. In Turkey, we are waiting. We are increasing the west. In the west, we are waiting, and we made it for European Union. We get data from Eurostat, and we made 6-year predictions. And this is our quadratic model we accrued, and these graphs we can see in the West will be increased, not like Turkey, but in the world it is changing country by country, and income values. For example, high income values, high income countries, we are waiting a decrease in investment management all over the world, but the lower and the middle income country, we are waiting increase to West generate. We are waiting, but not in the West management. As you know, ecological footprints are growing every year, country by country. But we are working on the Kuznets environmental curve, and but world is wasting every time. In the high income countries and in high income countries, we are waiting in decrease. But this is the most problem. This is became a problem in the environmental with environment. We are not living in Earth alone, but this is the most of the. This is I'm sorry. I will take it again. How we can do the decrease in middle income, lower income, and the lowest income, but we don't know. But environmental food waste makes environmental problems, carbon dioxide emissions, and the greenhouse emissions. For example, if we decrease the environmental, if we decrease the growing of environmental disaster for the food waste, how we can do, we don't know. In Turkey, we review at least 80 studies. As we can see, no one works with the environment for the environmental disease, but I think after this year, we must work on food waste, and this is environmental problem. I want to finish my presentation with a Turkish poet, Nazım Hikmet, to live like a tree, alone and free, and brotherhood like a forest. Thank you for your great attentions.
Thank you. Thank you, Becky, your presentation. Do you have anybody questions? No. Okay, thank you. Thank you very much.
Hi, all of you. We took a lot of contents in this meeting, so thanks to all of you for your very valuable contribution, and we are very, very happy of the contents that you took, of the talks, of the poster, and much more of the interactions we had all together. I think that most of us didn't meet earlier, so this was a good opportunity to meet each other. And maybe this can be a start of other chance to stay together. We're a pretty big community, and we started with a relatively low number, and now we are here. And we are very, very glad to all of you for this. I will just tell a few words because this is the last session of presentations. Then we will have, soon after the coffee break, the meeting of the different working groups. Then we will be here again to resume for everybody what's going on into different working group in the General Assembly. Then at the end, we have the Management Committee from 5 to 6 after last coffee break, where just the people of Management Committee have the privilege, the opportunity to participate. And you know that the cost rules involve 2 people per each country, so they are country representative. And so this meeting will be in this room, but the Management Committee will be not streaming online. So I saw that a big bunch of people is following us online. Also yesterday we had around 60 contacts, and today there are around 80. The video is on Facebook, and a lot of people connected, shared. Feel free to share these kind of resources. You will find yourself your presentation, and later we will mail you. And about, I know that some of you were surprised to be announced on Facebook, your presence, but you are funded by COST. COST is a public. Some of you was on Facebook without being on Facebook. But this is now the way that we use to share the information. Maybe after the meeting, we will think a little bit about, we will be nice to place all the contents that you took as a whole presentation as PDF, or even the PDF of the poster, the slides, and so on. The posters will be still here till the end. So in case you didn't do it, take the chance to have a look to the posters and to keep contact with the authors, to take names and to contact all of them. But even that material, it will be nice. We will ask, of course, that are public as well. So we will ask the PDF, and we can place in the different resource. We are glad to have all of you, but it took some efforts, but it was nice to have this meeting. And I want just to acknowledge the contribution of the different people that with different responsibilities contributed to this meeting. And starting with Marwa Momni, you can go down, you can come down. Marwa started to work from, wait, do not go away. Started to work from September going on, and she did a very good job. There are people behind the scene and behind that glass that made everything possible for have a smooth progress of the meeting. And Lucrezia D'Ortenzio, Lucrezia, you can get down. She collected all the presentations. She was very present, although we didn't see her, but although you were efficient to send the air with more or less advance the presentation, and she allowed to get a smooth meeting. We have Medea, that she was very efficient in taking pictures, and all those pictures will be, Medea, you can come, will be on the Facebook page. And we have a couple of guys, no, we have 3 guys that are monitoring everything, are streaming everything. So thanks to Comunicare Eventi company that supported us in a very well way. So thanks to you for your great work. Thank you. We had a secretariat that worked very well to host you and to prepare everything. Lucia Landi, she is one of the main components of the secretariat. And she was supported by Sarah Macau that managed the poster. You can go down, Sarah, Lucia. And there is Carmela, that she worked very well with Secretariat, and she also is linked with Moncaro, that is one of the sponsors of the meeting, and she provides a bottle of wine that you can take if you want home, or you can drink whenever you want or wherever you want. And this is a bottle of sparkling Passerina that is a relatively local cultivar. I like a lot, and for me, it is better than Prosecco, that is most widely known, but it is to you to give the judge to this, so feel free to taste and to take home. So thank you, Carmela, and if you want to ask something more to her, feel free to do during the breaks. A big bunch of you were funded by cost. So in case you want to be reimbursed, remember to place your signature on the form at the exit. In case you want to be reimbursed. And if you have any questions about the claim and about the cost rules that for some of you are, I know that some of you are involved in several cost actions. For others, it's the first time. And here there is Chiara Mengarelli. She invited all the participants to the meeting, and feel free to ask her whatever you want about reimbursement, claims, and so on. Cost, for those that knows, has specific rules. So you cannot get out, but that rules, try to study well them earlier so you can use the allocated grants at the best. And we propose this cost action all together, and as we will tell in the afternoon, we have together with the chair, we are the vice chair, that is Fernando. And he's part of core group, together to working group leaders, and all WUGI leaders are working very well. They will manage the different WUGI meetings this afternoon, and we met frequently to define the activities, and the first one of the activities is to fund some young researcher to spend a period in another country. And the people that is related to this, the person that is related is Pervin Kinei. Yeah, Pervin. She did a very good job. The decision was taken by all management committee, but the core group, but and of course all the criteria were defined by the management committee, and Pervin had a very great role in this. Then there is a science communicator office that Luca Falasconi, you met yesterday. You missed in this session because he just got tonight 39-degree fever. So say hello, Luca, that is following us online. Then there are the working group leaders, starting from George Karaogranidis. Working group number 1. Working group number 2 with Slaven Zialic. Not here. Okay. I think there is the co-leader, that is Luis Palou. Oh, here. Thank you, Luis. Third working group, that is, it is one that is more active till now, is chaired by Natalia Falagan. Natalia, are you here? No, she's around. maybe she's supporting the presentation, and she's supported by Lisa Corsten, you can count, and by Rosa Rolle. We are very happy to have you here, Rosa. And an interaction with FIO is very, very important for us, for all of us. Working group number 4 is on recycling and circular economy. So Jessica Girardi. Working group number 5, Sandro Frati. Together with Fatio Gul and together with Clara Montesinos, they are following online. Hello to them as well. And working group number 6, communication. Communication is very important. Kata Mihaly. He's here. Okay. He's here. Okay, so thanks to all of you for coming, for being here, for interacting, and now we are ready to take a break, then follow the discussion. Thanks to all of you. If we stick a little bit, they can take a group picture. Thank you. And in case you publish on social media, Slaven, go back. In case you publish on social media, you are welcome to share, and you can use the hashtag PostharvestAncona2024. Slaven, come in. Chiara, come in. Thanks to all of you. So we are here for the General Assembly to learn from which are the cooking things in the different working groups. Take in mind that the project is as a whole, but the different working groups has different sides, different angles. So there are some interconnection among the different working groups, and it is not possible to have the work on one without the others. But so I leave the floor. It will be a very short presentation, just 5 minutes, but from each of working group leaders. Then it will be a short presentation from the grant award coordinator. And then it will be the open discussion with all of you. The WUGI leaders sent some stone into the lake. So you are starting to think to the activities that can be run. Of course, it is a volunteer activity. So all of you are welcome to be involved with the time and the resources that you can dedicate to this project. And you are welcome to join 1, 2, 3, 4, or the different planned activity, contributing, collecting some data, contributing, resuming some issues, and at the same time, providing a valuable input that can be valorized in the way that will be decided along this trip. So I start to leave the floor to George Karaoglanidis, that is the leader of WUGI 1. You can also stay here if you want, and Lucrezia can scroll down, or no, you can also go to the computer because there are the presentation. Even here, okay. You can ask Lucrezia to scroll down the slides. Thank you. When it is possible, you can share the presentation. And George, feel free to go on.
Good afternoon, everybody. I'm George Karoglanidis. I'm the leader of the working group 1 that has to do with the prevention of food loss and food waste. We can change. Okay. Working group 1 is maybe the largest in memberships. I gave a look to the cost site, and we are 187 members originating from 29 different European countries and some non-European countries. In the meeting that we had a few minutes ago, we were around 6-7 persons. We had a very nice discussion. I would just like to present to you the main tasks of our working group. Lucrezia, please, could you? Okay, thank you. So we have two main tasks: the prevention of food loss and the prevention of food waste. That means that we have to understand and identify food loss or food waste from the farm to the retailer, to identify opportunities for sustainable practices that can be applied in order to reduce food loss and food waste, and to develop some information sharing systems or training programs to enhance the knowledge of farmers, of the retailers on food loss prevention. In total, we have, as a working group, 4 different deliverables. The first deliverable is the documentation and the synthesis of the existing main problems that cause food loss and waste. And after that, to produce a white paper about the impact of the loss and waste. Here, for the achievement of these 2 deliverables, and in order to be ready to provide the deliverables on time, we need your contribution. For this purpose, our colleague Natalia has already prepared an Excel file that maybe she will explain better than me later on its content, with which we will collect data on losses that occur in different stages. And our third and fourth deliverable is the preparation of a handbook and guidelines for recommendations to prevent, on how to prevent the food loss and waste. Here again, we need your contribution. I mean the contribution of the members that participate in working group 1. We have to review the existing published data in order to prepare this handbook. We can organize some training activities and some workshops or more symposiums to communicate modern techniques that we use to prevent food losses. And at the end, we also have to prepare, Lucrezia, please, a review paper on the prevention of food loss and waste. In the previous, in the meeting that we had a few minutes ago, I presented to the participants all these tasks, and then we had a discussion. During the discussion that we had arisen some concerns about the tasks. For instance, we were wondering if we have to collect only data from the last year, food loss data from the last year, or for a broader period of time, because from year to year, for sure, there are differences. Also, there was a concern about the preparation of the handbook, and we were wondering if this handbook will be a single handbook for all the countries, or a handbook that will take into account the situation, differences in the situations in each country. And of course, another issue that we have already discussed that, and I think that we have to do, participants recognize that between group 1 and group 2, there are a lot of similarities, and they propose to have some activities in common in order to facilitate the participation and the interaction among people that can contribute to both working groups. That's all from my part, Gianfranco.
Good, thank you, George. So we will have this short presentation from each of UG leader and what is cooking on, and then it will be the overall discussion and you can see how to contribute. Please, working group number 2, Slaven.
So, good afternoon, everybody. I'm Slaven Zjalic from University of Zadar, and I'm leading the work group 2. It's on food loss and waste management. First of all, just a short review of our task. We have to identify different management strategies, create roundtables, develop collectively new scenarios, determine appropriate new sustainable strategies, build consensus on potential new solutions. We have to establish links between conventional and organic farming to inform farmers that alternative or biological control can be usefully applied. Develop food loss and waste think tank, and create a platform for knowledge brokerage innovation. And our second task is evaluation of the potential to use innovative strategies to control post-harvest decay and loss. First of all, just from those tasks from, let's say, application from our project, it's clear that Working Group 2 is very connected to different other working groups, particularly to the 1, but we also saw to the 5. So I think that one thing that we agreed all should be a close collaboration between coordinators of the group, not to duplicate work and to share the information that we have. We agreed in today's meeting that we will at the end address all the possible influences on food waste and loss. So from those that are avoidable, potentially avoidable or non-avoidable, but also those directly linked to loss and those made linked to waste. As activities, okay, we have meetings, we will do our meetings online and once a year in person. We will organize training programs starting probably from the next year, when it will be clear also which of those training programs will be most important and let's say incisive for the work and for the development. We also thinking about this 2.3 as activity, this dissemination, which again comes together with work package 6, which is very important, and we will try to develop some strategies together with the colleagues from WP6. We have 3 deliverables. The first in order of time is a review paper, then followed by the protocol of best practices to reduce food loss and waste. And by the end of the program, we should have the guidelines for sustainable food systems. What was proposed and accepted by colleagues participating to today's work in this working group is to create a network. Now we have the people interested who express their interests to collaborate within the working group too. We have also decided to focus surely on two producing chains, so one related to fruits, one to the cereals, and depending on the interest of other participants to the group, one dedicated to vegetable production as, let's say, a kind of pilots or extensive guidelines that could follow afterwards. We will launch the call for the paper for the persons interested in developing this review paper, and I'll try to do it as soon as possible. We'll discuss on the best way to do it, and we would like to start our work by the beginning of the March of this year, and would like to collect all data by the end of this year to be able to organize a workshop, organize the writing, and to present the paper before the summer of the next year or within the summer of the next year. We consider this paper, let's say, as a ground floor for all of our activities, because the results of the paper will be used also in elaboration of the protocol, and we will also use it as a guidelines for sustainable food system in 48. And we have decided, as I already told you, that for sure we will have one chain of fruit production, and we will have one chain of cereals, and if there will be interested also in vegetable production. And of course, animal production is not included, but at our working group, we had nobody from animal sciences, so for the moment we left this part out. Thank you for your attention.
Thank you, Slaven. Of course, this is just a start, and there are just some notes. If some available people will enlarge this platform, they are more than welcome. So everybody, that is every of over 350 people that join the working group, are welcome to take their contribution. So if there is something that it is not covered in that working group, and you can or you want to produce a contribution, feel free to tell, and we will enlarge this platform. Now it's turn of the third WUGI leader, Natalia Falagan, for food loss and waste measurement, quantification.
It looks like the Oscars nomination, like Natalia Falagan for WUGI 3. Anyway, so we've been discussing this afternoon with amazing input from the participants. So I'm going to try to explain what we are trying to do, but also what we've been discussing in the session before. This is the short version. So anyway, the idea that we are doing in QG 3 is to quantify losses from both perspectives, all the losses that are linked to management, logistics, but also the behavior. So we have mainly two outcomes or two milestones. One is getting this framework in place and getting as much data as we can, with the idea of sharing that knowledge and then link with other working groups, like, for example, working group 1 on prevention. So we can basically link and get these mitigations and actions and guidelines. And then the second one is training and understanding, raising awareness and improving education. That's something that was mentioned yesterday, in the importance of the role of the consumer and the importance of awareness. I'm leading this working group, but this working group is co-led by Lisa Constant and Rosa Roll, who I'm sure gonna give an amazing value and with their experience to this working group. At the moment, we are more than 100 participants, but you can still apply to join the group, and your views are more than welcome. So I'm going to give you an update on activities. So as George mentioned, we have developed a very basic framework where we have focused on food loss and trying to understand where those losses are happening, how much is being lost, and also the why, what drivers are linked to that loss. So that is waiting for the core group feedback, but during the discussion this afternoon, we have realized and it's been raised that it is very important that this framework is to a certain extent bespoke for each country, because each country has different challenges, and some countries are very open to share information, or the industry in those countries, some others don't, and some other countries are going through conflicts that literally cannot be thinking about this at the moment. So once that final version is ready, the plan is to share with the representatives of each country and relying on the networks to be able to fill out that Excel file. And that data needs to be robust and reliable. So it is really important that we not only fill out the data that we find, but also include the sources of that data. So where that has come from, if it's a paper or any government report, it needs to be there. If it's conversations with a company, it needs to be there, and it needs to be validated. And all that will go into a report for the Cost Action Food Waste Stop. And then afterwards, we will share and upload that information into global databases, like, for example, with FAO, so that data is publicly available and accessible for everyone who is interested in it. The Excel file, as I said, is meant to be very simple. In previous experience, I found that having a very complex framework discouraged people to fill it out. So basically, you will be able to select through a drop-down menu the country, food category, fresh produce type, fish, meat, dairy. Even though for us all food loss is important, at the moment the priority is fresh produce because it's the food category that has the largest rates for food loss and waste. Then we will link to cost, so product price, total amount produced, total amount lost or wasted, and then the driver, so the reason behind that loss. So in the discussion this afternoon, for example, quality standards have been raised as an issue in many countries, so that's something I will be including. But if anyone has any views around this, please let me know, contact me, and we will improve this framework because it is distributed. The second part is the waste, where the behavior of the consumer is a key driver for waste worldwide. And we are lucky enough to count on Luca Falasconi from Waste Watch International, who has shared with us a list of questions for a questionnaire that we again will be releasing to the country representatives so they can roll out this questionnaire to consumers, and we can get some data in the form of more questionnaire around citizen science. So again, that data will be analyzed and validated by the core group, and that information will be again shared as a form of either a peer-reviewed paper or a report, and again will be shared with FAO as an international organization. The idea for this group is for it to be highly collaborative. We think that it's important to have a holistic view and understand the different approaches to this issue. So highly collaborative, high number of authors if a paper comes around. So please do contact us, because the idea here is to generate knowledge rather than an increased transparency. And the other point is the summer school we are organizing at Cranfield University during the second week of July. This is in the UK, in England. We are seeking for up to 30 participants, and the idea is to provide more conceptual, so fundamental knowledge on food loss and waste, but also a lot of technical knowledge on how these are happening, why, where, what knowledge do we have at the moment, and how we can increase that information. So that will be based on master classes, practical activities and case studies, and industry visit. The timetable is to be agreed, but we have these tentative options where, as you can see, we will be touching on root causes of waste, temperature, ethylene, safety. Then Rosa has kindly offered to kind of talk to the team of statisticians and FAOs, so potentially they can be involved, and mitigation actions. So that would be in July, so it will be announced very soon. So please keep in touch, have a look at the webpage, and be connected through us with Twitter, Facebook, so we will announce all that there. So thank you very much.
Thank you, Natalia. And now we move to Jessica for VG4.
Hi, everyone. So after the quantification working group, logically is coming working group 4, who will focus on the valorization of the agro-food waste in a circular bioeconomy concept. Actually, with the meeting of today, we started to reconsider the definition of agro-food waste, because in our specific working group, we prefer to consider the starting material for the valorization in a different way. So we will agree, at least internally, to call it in a different way, or at least to include the loss as well, that it's a part of the material that can be recycled. And the objective of the working group is the identification of the different source of the byproducts of the agriculture. And in this specific task, actually, we already will have the information coming from the quantification working group. So we will know already which are the main products and the quantity that is produced. And for each kind of byproduct, we will define a different path for upcycling it. And we will also design a circular-based framework for the production, consumption, and reuse of specifically the food and vegetable and cereal side streams. And we will move from the basic arrow way of the food chain to more circular, including also all the innovative strategy to valorize this product. And we will also need to map all the existing technology available, that it's something that we understood today in our interaction, that it's already ongoing. So we will just need to put together all the information that we already have from our work and in the country where we are working. And it will be important to define which is the value added of the final product that it's possible to produce with those technologies. And in the moment that we realize which kind of strategies we might rely on, it will be important to underline which are the challenges in the implementation stage, when we want to approach the industry in a moment to make possible that this strategy is actually reaching the consumers. And about the deliverables, our deliverables are not so immediate in a time frame, but still, first of all, we will need to list all the bioactive compounds extracted or produced from the food and waste, fruit and vegetable waste. And after that, we will be able to prepare guidelines for the new valorization strategy. And this will go simultaneously with the review paper on valorization of agro-food waste. And also for this part, we understood that we are pretty strong because we, in our working group, we have a lot of people who are focused already for some times in this. So will be really fruitful to put all this knowledge together. And last but not least is the development of at least 4 potential application of this valorization strategy. And this can come in a different way through some startup, spin-off university, or some actual activities that are already starting in the industry side. According to the memorandum, these are the activities that we will need to reach. So we will have several meetings. We will see how much meeting we can organize in person, but for sure we can have a lot of meetings online. And one of the main topic that it's mentioned in the project, and we agree that it's quite interesting in terms of valorization of byproducts, is the effectiveness of bioconversion by insects. And second activities will be the approach of the consumers, the farmers, and the public that is interested in our work with at least 3 campaigns. And the idea is to raise the awareness of the importance of the upcycled products. And here I just list some focus points that we touch today together, and that are just following the deliverables and the tasks that we are asked to follow. So first of all, the review of the existing published data. And we will try to have as much as possible direct interaction with organization and industries. Would be really nice to have interviews with experts in this case. We agree that we need a standardized methodology to compare the results that are coming from the different country we are coming from, and to clear the informative and the legislation that it's applied in each European country, because this can make the difference in which kind of strategy is actually possible to apply in the next future. And regarding the case studies, as I mentioned already, in the case studies will be really important to also include the economical and environmental footprint evaluation. And we are really lucky to have in our working group people who are in this specific field who can really help us. And finally, the social network platform to connect different industries who are working in the same area, more or less, that have different side stream or are interested in utilize some byproducts that they don't have, but they have the technology to reuse. So in this way, we could match and connect the different industries and optimize the reverse cycle logistics. So we will not have trucks who are running on the road from one country to another country just to transport these byproducts, but we will try to figure out solutions that are more sustainable in the geographical area. And this is just to underline that we are the biggest group, actually. Currently, we are 244 members, and we had a chance today to introduce each other with the people who were in presence. And we will schedule the working plan and create subgroups, because we are really heterogeneous working group members, and each of us have specific skills that can be puzzled with the other members. And in this way, each of us can feel free to help in any tasks that he feel confident. And one of the first decisions to make will be about the standardized method for mapping the food system in our context. So in the identification of the available source that it's possible to valorize. And that's it for me. Thank you.
Thank you, Jessica. Since the activity was so big and the people were so many, you took more time than the others, so it was worth because you have to explain everything. Thank you. Now is the time of Sandro for VG5 about the innovative tools that we can use.
Yes, indeed. So good afternoon, everyone. I have also quite a few information to share about the VG5, which is a cross-cutting technologies, a smart system for food management. So basically, this I took from the memorandum of the project. It's about exploitation of smart technologies for optimization of post-harvest processing, transportation, and distribution. Obviously, also with the purpose to avoid as much as possible food waste. So the key objectives that involve the VP5, I agree with what the colleagues already say, that there are many of these objectives that will be related to multiple VP together. So we're going to collaborate a lot and to put really our strengths and resources together. Anyway, what is involved today, evaluation of at least 4 innovative concepts in food waste prevention that can be conducted at the European and global level. Identification of at least 10 potential ideas for upcoming EU project goals. So goals obviously that focus on this kind of topics, on innovation, implementation of a solution to reduce post-harvest food loss, to extend the shelf life of perishable food products and so on, and also dissemination of results. Provide a disseminated list of action for stakeholders such as policymakers, growers, grower associations, and so on, food, retailer, even consumers, with practical measures to reduce of at least 50% the loss and waste, and also favor the participation of at least 2 near neighbor countries in all people also from all 22 coast countries in the actions. So our task would be to collect available data and assessing the impact of food safety aspect of this important topic, to identify also significant hazard that might be present, to understand the role of social economic empowerment in food waste reduction, identify strategies, of course, that can bridge the gap, identify and explore new integrative and innovative smart solutions, because there are. What we need to know is to put everything that is available together and develop it further to understand really what can be used, and assess effective governance for food loss and waste, and provide guidance for policymakers. So among the foreseen activities, I thought to highlight these. So establish a network, because it's really, really important to really put all our brains and activities together. So network on social media for commercial food surplus recovery, for donation to food banks, organizations, and so on. And also a network of secondary market interested in redistribution of imperfect products. So an activity that would focus and valorize let's say the type of food that is no longer first choice. So basically we had a bit of brainstorming. Our group was really interesting. We were saying that as a start, we should put together a list of all these technologies available today. There are many. Some of them are available at commercial level, others no, others are research ideas, but it would be really important to put it all together, both through, as a start, like the colleagues already said, through analysis of scientific literature, review of scientific literature, but also with the contribution of all the members of this project that hopefully will provide some ideas should they have something in-house. That was quite a concise summary. Thank you. If there is any question, we'll be available. Thanks.
Thank you, Sandro. And the involvement of the industry is very important for this project because we have to create a link, a bridge between the research and the public. So the involvement of the industry is crucial. Last but not least of the WG is WG6 on communication. Kata.
Yes. So working group 6 is about networking, dissemination, communication, and transfer of knowledge. This is how I see the working groups. A little bit complex, but we are in connection with each other. And every working group has its own research work, and they work on it to reduce the food loss and waste. But working group 6 is a little bit out of line because we don't have a specific research topic. I think we are the bridge between the researcher and people. So, of course, the first important thing is to find the solution to reduce the food loss and waste. And after, we should show this solution for the stakeholders. So the working group 6 is help the interaction, the contacts between the researchers and the stakeholders, and we try to fill the gap between the science and the people. So let's talk about a little bit more the objectives. First, we need the communication plans and platforms. We should make visible the cost action in European international level. Try to involve contributors as widely as possible and have the communication with the stakeholders and disseminate the results of the working groups. And the end of the project, we will prepare the 10 golden rules. How can we achieve it? The social media platforms are ready, and the website is under progress. And we should share information about the training tools, the conference, the SDSM workshops. But these two tasks is responsible the communication coordinators, but we work closely together with them. And we need to identify and determine the exact stakeholders, and we need to publish open access research article, but not just that. I think it's more important to publish research results to technical magazines which are understandable for the general public. And we need to produce handbooks, guidelines, protocols, training videos in several languages, and distribute them as widely as possible. And I think it's important to find the young generation and make and do educational programs to spread the knowledge of the results of the action. So what is the next first steps? First, we need a budget for the media, but we have this. And we need to gathering and creating as many contacts as possible. And the work, I think, can be easier if we identify 1 or 2 persons from each working group who will be responsible to forward the latest results and summarize to the working group 6, and dedicate 1 or more person from each participating country who will be responsible for publishing the news in their native language. And that's all. Thank you.
Thank you, Kata. And post-action has to spread the grants that the EU provides to foster the education of the young generation, to promote the interactions. And then there are the first action that actually started is to open the call for short-term scientific mission. And here there is Pervin Kiney, there is the grant award coordinator that did a very good job in this task. And Pervin, if can you tell us a few words about that?
Okay, thank you. presentation. Yeah, okay. In this project, as Gianfranco told, we did the first call for the STSM, and we first of all, of course, we need to put the criteria, and all the core group work together, and we put the good criteria. And in these parts, we did the first call for the STSM, and 7 application we got. Could you move the? Okay. What is our main goal in these parts? Of course, in these parts we need to. Thank you. A short-term scientific missions and some virtual mobility for the also young researchers and other researchers, and virtual network supportings and ITS conference, also training schools. It was the R8 aims. And could you move, please? So we put the criteria as you see here. We did a good job with all members, and this is the criteria. Could you move, please? And applicants ranked according to this criteria, please. This is the first calls for our project, and it will end now, and the applicant already choose. Could you move, please? And this is the first call. Yeah, please. And 7 applications we got, and according to this criteria, 5 applicants were approved and awarded, as you see in the table. And you see there is a 500 budget. It's because of the she accepts this budget for these actions, and now we have 5 young research supported in this STSM. Yes. Now, next is the training school in the Cranfield by Natalia, and I think we will do the next call for the STSM in a short time. Thank you so much.
Thank you, Pervin. So we wish all the best to those young researchers. There is a code that is called Young Research Innovators, that are people with less than 40 years old. And then one of the aim of the cost is to support this. So this was the first meeting of this cost action. It was new for most of us, including me. And we try to do our best, but I think we can further improve. So if there is something that can be improved in the next meeting, please tell us. And the WUJI leaders told which is cooking and what is the frame in which all of us can be involved if we want. We have targets that are closer, targets that are looks longer, but is tomorrow. And anybody tells that we have to place the deadline on the last day. We can start soon, start to collect the data, to organize them at best, see clearly the people that wants to be involved with a valuable contribution, not to do just because it will be a review one day and I want to write one line, but it should be a valuable contribution. So choose yourself to be in or out in all those activities if you want to join. We had in this meeting over 100 people, around half were funded by Post. So thanks to all the others that came with their own grants. And we had a good bunch of people that were connected. Yesterday were 60 people that were connected. Today I saw there were 80 registered. We will see the actual data. So by our point of view, we are satisfied of this interaction that we had. And I give the floor to the vice chair, that is Fernando personally.
Okay, thank you, Gianfranco. Just to a little bit summarize what we talked today and with the different BG meetings. I just took some keywords that I think is important that we consider for the next steps in the cost action. I just wrote integration, the things we are having a diversity of different solutions, so we need to integrate this. So we also discussed in our visit about the importance of this systemic thinking when we want to solve the food waste and loss. We need to consider all the links in the food chain, so this we cannot forget any link. So we have to consider this chain when we want to just to be effective in food waste reduction and prevention. So integration, systemic, synergy. So we need to be synergistic in our approach. So we have different solutions, different people, different views. So we can combine to even some more than every isolated solution. So and networking, I think networking is important. So these days I realized that we can learn a lot. There are many things around that didn't realize. So it's important that we still keep this networking between us, so we have chance to projects together for collaboration, just to exchange knowledge, just to know what is the next is doing. Many things, and it's always difficult to be the last because everything's already done, at least said. So, but at least you have the advantage that you have the information that the others are delivering to you. So I want just to emphasize something which is more practical. I think that we need to use some kind of electronic tool apart from the website and so on. Maybe I will discuss with Sandro in our meeting, just to collect what we are doing in our labs, what is our solution, which is our methodologies. So that way we can just probably advance more quickly and see who is the right one just to progress on our solution. So okay, so I think it's time just maybe you can also contribute now, just giving us your opinion about these 2 days, and also about the meetings in which you were participating.
Feel free to raise hands to interview, and take in mind that we can have some budget left from this meeting, and since we saw that it was a good interest for this short-term scientific mission, we will have a call likely at the beginning of March. And in the month of February, we will have a call for the training school in Cranfield. So be ready to apply by yourself or ask to your younger colleagues to apply, because I think that can be valuable growing opportunity. Last thing is that I'm very happy that 2/3 of the overall participants are still here. So thank you so much. If somebody wants to provide a contribution, now is the time. Okay, Dom.
I think that working group one and 2 should be together, also in the planning, because they are very similar. And I think working group 1, they have the chairman has supported that idea. That's something to think about. Concerning what the valorization, we are not. We are here in dealing with innovation in food loss and waste management. The valorization that you just reported you want to do is almost a new project. Tremendous amount of work. You know, you have to be a little bit realistic. What can be done between your normal work and contribution to the cost. I don't know if it's the first cost action that you are here, because it's not so easy. Anyway, it's something you have to think about that. And the third point is the how wide are the subject of the meetings. You know, try to put together something that, for example, it's important for logistic and food protection. Maybe try to put together something that makes more not only separate logistic and food protection separately. A lot of things have a similarity, and they need to be together, because in normal conditions, I was talking with people from logistic, and he explained me things that I didn't know. So it is important to try to make mixtures of very specific things, and overall to be realistic about here what we can do in these conditions. And third, that the chairmen of the session should not only call for the names, they should learn about the talks that the people give, because it's not only the chairman should try to come and always ask a question to the person. It's a matter of running a meeting, and that's why it's not only let's call the Dov Pruski that is coming to give or who else, but you have to learn about a little bit about what the person is trying to say. So you will have to always to have a question, even if the public don't ask. This is also important, how to run things here in this type of meetings.
Thank you, Dov. There are other, we are taking notes. There are other feedbacks, yeah?
So I was just wondering, because the terms that you used between the working groups, let's say, starting from the food loss, food waste, then agriculture side streams, then agro-food waste, then organic waste. So I think that we should define these terms and to use the same terms in each group.
Okay, other feedbacks? Please.
I want to say, first of all, Gianfranco, fantastic what you've accomplished and your team. This is not easy to bring together so many people. I must say, in the beginning, I was a bit surprised with the mix, because I just thought of fresh produce as waste, and you have included meat, etc. So in the beginning, I thought, no, it's too big. Maybe just focus on fresh produce. But, you know, we can always learn so much from the different food systems. I also like the combination of, you brought nutritionists in, AI people. And that's extremely important from a transdisciplinary focus. And I saw the willingness to get involved and collaborate and work together. So that's fantastic for the past 3 days. I also like the emphasis on outputs, publications, review papers, and then obviously the input in policies and the regional, and getting FAO involved. I think that's extremely important. That will internationalize this and really give it a sustainable long-term focus and vision. And the indices. So I think this is a fantastic start meeting, and we are looking forward to working together with everyone. So thank you.
Arthur? Ashraf.
So first of all, I would like to felicitate the core group for this organization. I was really surprised that about the respect of time, about the social program, about the multidisciplinary approach of the meeting. So it was really a great job. Just one comment about the organization. Maybe in each session, at least after finishing the presentation, the moderator should at least prepare one question so that the speaker feel about the importance of what he talked about. Otherwise, if there is no question, it's like, okay, maybe it was not interesting for all the people. So just for the moderator, there should be at least one question in case that the audience didn't have any question or interaction. Then for the work group, I think you have a lot of contact with the PRIMA coordinator, and I think there is some deliverable which are, let's say, similar to some deliverable from other PRIMA projects, especially in the agro-food. So I would say that you should be in close contact with the coordinator of the PRIMA, and you can jump in some activity already for the dissemination, because many PRIMA projects have this dissemination work package. So they are organizing like events, cooking class, or contact with consumer and contact with stakeholders. So you can already maybe prepare flyer or some disseminating tools and use them in this different events of the other PRIMA project activity. So this is my suggestion, and congratulations again for the organization of this event.
Thank you. Further feedbacks? Okay, so we took note of all what you told. First, we are to start from the cost rules and from the cost aims. It means that cost is a project of networking, of interaction, and supporting of different areas of Europe to make them more uniform. So it is not a top-down project, but it is a bottom-up project. Then we have to think not on what cost can do for me, but what I can do for cost. And it is a volunteer work, potentially can be huge, but it depends on how much energy we can dedicate to this activity. Of course, into the cost, there are a lot of PRIMA coordinators or PRIMA participants, but not just PRIMA, European project, networking project, but even a lot of people that did not have this chance, but wants to learn, want to develop, want to connect, interconnect. We had people from South America that flew here and took his expertise, just to give an example. So potentially we may do a huge amount of work. Realistically, we will place together all the drop that each of us can take to this project. So we can create the container, but the drops are all of us. And we can just try to put together the best that we can collect in the time frame, with the time rules, with what it was written into the project and was approved by cost. And this is the first meeting. Of course, we can improve, but we decided altogether to have very short talks, but to allow to everybody that tasked to participate to tell their own story. And first, to have the talks, you have to stay within the allocated time, because if you want to tell more, there is no time, because you take the time of the other speaker. It is a general, okay? So for some talks, it can be some question, for other, no, it depends. I think that for many of the talks, there were a lot of other questions during the session, during coffee break and so on. It is a way to interact and to tell in the shortest time possible one story that can be a poster, can be a talk, can be an interaction, can be a shaking of hands and so on. So I can thank, we're perfectly in time for the coffee break. So I thank to all of you for joining this session. I say hello to the people that are connected online. And then we will say hello to the people that do not join the management committee, because at 5 here it will be the management committee, but it is restricted to the management committee members. Being in the management committee is a responsibility that the people that join voluntarily took. There are 2 representatives per all the countries. So you are, if you are part of the management committee, or you are part of the working group as a co-leader, you are invited to this management committee. The management committee will take some sensitive decision on what it is going on with the project. So I ask to the people of the management committee to take a coffee and be back. And I say hello to all of you, and thanks for the contribution that you took to this project. Thank you.